All right, good morning. I'm Tim Peters once again, state engineer with NRCS out of Harrisburg, Pennsylvania. Thanks for coming back for our session number 2. This is our virtual session number 2 for Boot Camp Basics. So we had our first session last week. This is our second session. The in-person is going to be held either next week for some of you or in May for others, and then we'll have a third virtual session that follows the second in-person group. So I did want to say we have a conflict today with the training. There is an Act 38 course that overlaps today, so we do have a little bit smaller group attending, but we are recording this and we'll be providing that recording to anyone that missed or anyone that would like to review anything from the virtual session. Like I said, next week will be our first in-person group, though. So if you're attending in person next week, if that's the week you're assigned, we will be meeting at the Union County Government Building on Monday morning, and registration is between 9:30 and 10 o'clock. So we'll get started right at 10 o'clock on Monday. If you are not next week, if your in-person training was assigned for May, please note that you won't be at the Union County Government Building. You will instead be at the Best Western, but more info will be coming out about that and reminders will come out about that. So for those that are attending next week in person, please pay attention to the items to bring list that Shannon Winger has provided. Especially make sure you have boots that we can use for biosecurity for washing. We're going to practice good biosecurity everywhere we go. Make sure you have a water mug or cup or something to take to the field. We're in the field every day. And make sure you have a coffee cup if you drink coffee, or I use the same one for both, so that's fine too. But make sure that you have something to accommodate water out in the field. And the weather is going to be a little bit iffy next week. Unfortunately, it looks like there might be some rain and it's going to be chilly. We are going out though, and that's part of the job. You know, we go out in the field when we need to, regardless of the weather. And so we will do the same for our training next week and dress appropriately. Make sure you have layers. Make sure you have something to protect you from rain or keep you dry, especially I think on Monday is the day that looked most like rain. And then I think Thursday and maybe Wednesday were a little bit chillier with highs of around 45 or 47. So it is going to be colder. So just wanted to make a note that make sure you have a coat and are warm so that that's not a distraction during the training. With that, I really don't have anything else. So thanks for being here. Thanks for attending. It's exciting. Next week's really exciting for us. We're looking forward to it. But with that, I'll hand it over to Chris Canfield. So Chris, thanks a lot for taking over as moderator today. And well, I'll look forward to seeing everybody in person either next week or in May.
Thanks, Tim. One other thing I will add that you should probably bring, and I think it was on the list, but an old towel or a rag or something to wipe your hands when we go into the soil pits. And that is Tuesday and Thursday, I believe. So you'll want something to kind of wipe your hands off when we're out in the field. My father-in-law does say that Lewisburg is the windiest place on earth. So definitely bring gear for breezy. If you have any questions about Lewisburg specifically, I'm going to put my email in the chat. I live right in Lewisburg, so if you need to reach out for anything, please feel free to do so. First up today, we have Jen Weld. She's going to talk about cropland conservation as an introduction. Jen, if you are ready, you can share your screen.
Okay, so everybody should be seeing my just title slide at this point.
We're seeing the entire document right now. It's not in presenter mode. Yep.
Yep, great. There we go. Should be in presenter mode now.
Perfect. Thank you, Jen.
Sure, thank you. So good morning, everyone. My name is Jennifer Weld. I'm with Penn State University. I joined you last week to do an overview of the basics of soils. And today I'll be presenting just an overview, beginning of a discussion about cropland conservation, some common conservation practices that you'll be seeing in Pennsylvania. I'm presenting the presentation, but it was developed by Tyson Myers with USDA NRCS. Again, kind of a joint partnership here as we work with NRCS on this boot camp initiative. So some common cropland resource concerns that we often discuss when we're in the field as you start your field experience next week reflect soil health. So soil organic matter depletion, losing soil itself through erosion or soil loss, and therefore depleting organic matter, or perhaps having bare soil for a part of the year. Also compaction. With equipment moving across the cropland, across the surface of the soil, you're going to have compaction. We talked about some changes that you can see, for example, in soil structure. You can develop a platy structure in the first 6 inches of soil when you have compaction. You can also have aggregate instability. So your aggregates, as they get wet, your soil aggregates, again, which are your organization of small kind of clumps of soil, which are important for soil structure and soil aeration and root growth, can become unstable. So if you have a lack of organic matter, a lack of microbial activity, maybe a lot of soil disturbance, you can also have aggregate stability, which promotes erosion and soil loss. And this all combines to reducing the habitat or the environment that's suitable for soil organisms, which is incredibly important for soil health and for our soil ecosystem in general. So there's several different pieces, soil physical concerns, property concerns, as well as soil microbiology or biology concerns when we look at soil health and how managing the soil for crop production can influence that. Over here on the right-hand side, over here on the right-hand side, you can see, let me see if I can access the pointer here. There we go. You can see an image of gully erosion. This is a type of erosion that can occur on the field, which is a cropland resource concern. It does influence soil health and soil physical properties because you're actually losing soil, you're incising the landscape. These types of gullies you can see here can become very deep, and they will become deeper, but they will also start to incise from the point of where the water's starting and move backwards as well. This type of erosion is a concern. Intervention is definitely needed here. Just from a management standpoint, this is a concern for moving equipment through the field or animals through the field. So that is one form of erosion that is a cropland concern, is gully erosion, often the result of concentrated flow areas. Another type of cropland erosion, which is a resource concern, is what's referred to as sheet and rill erosion. And this particular image shows examples of sheet and rill erosion. And you can see that the areas where there is rill erosion occurring are not as deep. They kind of follow the overland flow pathway here. If you follow the pointer, you can see some of them. Sometimes rills, especially interrills, which are small rivulets, will kind of be present during an individual storm. So as water moves across the surface of the soil as a sheet, which is why we call it sheet flow, as opposed to concentrated flow, where it's moving more as a channel, where you get a gully, you can start to get these small areas, which are called rills. You can also get what they call rivulets, which are very transitory. They're temporary. They occur during an individual storm. They can occur on different parts of the land. And then once the storm is over, or the series of storms is over, those rivulets will disappear. So it's a different type of erosion. It is caused by different water flow characteristics and landscape characteristics than concentrated flow, which results in gullies. However, you can still lose a substantial amount of soil, changing some of those resource concerns around the soil physical properties, such as aggregate stability, but also the biological properties, such as the environment for the soil microorganisms. It's this type of erosion that results from that kind of uniform flow across a hill slope, known as sheet and rill erosion, that is estimated by the Russell soil loss calculation. That is part of conservation plans or part of Ag E&S plans. If we flip back to a moment to this gully erosion, which typically emerges on a landscape or in a field because of concentrated flow, this type of erosion is not estimated by the Russell equation. It is reflected in other locations in the conservation or Ag E&S plan through the implementation or placement of best management practices, and we'll look at a few of those, but it's not part of that Russell equation. So where you see gullies emerging, areas of concentrated flow, they need to be noted, as well as these areas of sheet and rill erosion. So you can have multiple types of erosion, multiple types of land flow, causing different combinations of resource concerns occurring on a single field or a single series of fields or strips. So the Conservation Catalog, which is a publication from NRCS, is an excellent overview and kind of inventory of, has some very nice images of conservation practices and the types of resource concerns that they address. So we're going to look at a few best management practices that would be included in that catalog, also included in the NRCS Field Office Technical Guide. But before we begin, just kind of defining in this kind of space what we mean by best management practices, because that can be a very broad term with multiple definitions. But in this space around conservation, planning, ag E&S planning, it's practices that reduce or mitigate resource concerns on cropland. Sometimes there's multiple best management practices, or can have a conservation system that integrates multiple best management practices to address different resource concerns on the landscape. But that's kind of our definition in this space of best management practices. So we're just going to step through a few conservation practices, how we look at conservation practices, and the types of resource concerns that different conservation practices might address. So a conservation crop rotation is a sequence of crops grown in the same field or the same area of land over a period of time. And it's a planned sequence. It's an intentional sequence, and sometimes is referred to as the rotation cycle. This type of planning of crops and how they're grown on the same kind of field or series of fields can be very important for reducing sheet and rill erosion. We just discussed that's one of the forms of erosion that can occur on fields. It maintains soil health as well as organic matter content. And that becomes important when we start to talk about aggregate stability, maintaining that soil structure, which is very important to make sure there's enough both soil air and soil water, and also that roots can penetrate down into the soil. By controlling sheet and rill erosion, you can also control the loss of associated nutrients, reducing the impact to water quality. But there are some other purposes or kind of resource concerns that are addressed by the conservation crop rotation that are outside of kind of soil concerns. You can reduce pest pressures on plants. Sometimes when we look at these best management practices, there's also opportunities to bring in those types of benefits or purposes. Also, you're looking at feed and forage for your livestock if it is a farm that produces animals. And these types of crop rotations, as they're being planned, can have a purpose of providing habitat as well as cover for wildlife as well as pollinators. So we just stepped through, several different purposes, ranging from soil health to maintaining soil aggregate stability to providing cover habitat for wildlife. And these types of considerations are known as purposes, again, in this conservation planning space or in this conservation space. And this is the purpose that this particular best management practice, which is the conservation crop rotation, can be used for. It may not meet all of these purposes, but it can be used for a subset of these purposes, right? So as you're working through recommending or working with the farmer or the land manager to identify the appropriate best management practices, speaking to them about what are your goals, what are your objectives, maybe what are your concerns? Are we already seeing areas where we know we have sheet and rill erosion, or areas where we can see that there is water quality or potential for water quality degradation? And you can start to put different best management practices together that have purposes that help to meet those goals or to address those resource concerns. So as we step through our best management practices, we will look at these purposes. This is an example of the conservation crop rotation, just some images of what that looks like. And you can see up here in the upper left, you can see these different sequences of crops, and you can see that very clearly. So common crop rotations that you'll see in Pennsylvania Corn grain and soybeans, very common. You'll often see corn silage, small grains, and then alfalfa and hay, which each of these crops being grown in the sequence of crop year. So crop year 1, corn silage, crop year 2, small grains, crop year 3, alfalfa and hay. So these are some common rotations that you'll see. Contour farming is another practice that is used to address resource concerns that you will see in Pennsylvania. It's basically aligning the ridges and the furrows and the roughness of the field. This is formed by tillage and planting practices, just agronomic practices that are necessary for crop production on the grade. So basically following the contour of the land as you are planting and as you are kind of managing the land, but also identifying your fields. By doing this, by putting the crops and the fields on the contour, you can change the direction, but also the velocity of water flow. And this serves multiple purposes. Again, we're looking at reducing sheet and rill erosion. If you're reducing the velocity and direction of water flow, you can control that soil loss. Also, you're reducing sediment transport to water surfaces, surface waters. So you're controlling the soil loss within the field, but you can also address the soil loss from the field into a receiving body of water. Again, the associated nutrients with that would also be controlled. And also looking at pesticide transport as well. So as we control surface runoff or water flow, we control sediments, we also have the opportunity to address nutrients as well as other chemicals such as pesticides that could be moving with those sediments or water. And as with the crop rotation, you can also improve soil moisture management. So again, coming back to the soil properties that are necessary for crop production. This is an example or some illustrations, photographs of contour farming, and you can see in both cases in the upper left as well as the bottom right, you can see these fields that are aligned according to the kind of the contour of the land. They almost look like a topographic map, right? They're following that topography and have been laid out accordingly, and this will reduce as well as direct the water flow. So strip cropping. So strip cropping is growing crops in field strips where you have erosion resistant and erosion susceptible crops kind of in a sequence. It's a very systematic arrangement of fields, sometimes very frequently combined with contour farming. So you're controlling not only the water flow, the water direction, but now you're moving into combining these erosion susceptible and erosion resistant crops, so further controlling soil loss from the field. Again, we're looking at this transport of sediments by sheet and rill erosion, controlling that surface hydrology, that surface water movement, to also control nutrient loss, sediment loss, pesticide loss. And this can improve plant productivity and health. So very similar purposes to your contour farming, which is why you often see them working together, both of those practices working together, along with a crop rotation. So this is an example of strip cropping. You can see these alternate strips, and we saw this with the crop rotation as well. But the unique piece with the strip cropping, and we see it down here, is you may have hay, oats, and corn, where in this sequence, you're going to have crops that are very susceptible to erosion because of their residue or their cover or their management, and those that aren't. So as you have soil that may be lost, for example, from a small grains strip, it may be trapped in the hay strip. So it is, again, rotating your crops, but planting them in a way that you are organizing them according to susceptible and resistant crops and management for erosion. So cover crops is another best management practice that definitely plays a role in how we manage our crops, our agronomic production, to reduce soil loss, as well as to change or to reduce surface runoff. And cover crops are grasses, legumes, or forbs, and forbs are generally herbaceous plants that are not grasses. that are planted on a seasonal basis to provide vegetative cover. So oftentimes you'll see them over the fall, so you don't have periods where you have bare soil, right? Keeping the soil covered. Cover crops can also be planted with multiple types of crops together, often called a cover crop cocktail. And oftentimes you'll see on dairies where that second crop or that cover crop is a commodity cover crop where it's being grown for forage, for feed for the animals on the farm. So there's multiple ways that cover crops are integrated into the cropping systems in Pennsylvania. But again, we see some very similar purposes that we were seeing with our strip cropping, with our contour farming, and our crop rotation, is that we're looking to reduce that erosion. In this case, we don't see much wind erosion. I say that after this week's and storms up here in State College, but mostly we have water erosion. Again, you're maintaining soil health and organic matter content, which helps also with nutrient cycling, but also with aggregate stability, right? Our soil physical properties, reducing the risk of water quality. But now we're sort of getting into the opportunity to look at weed pressure. With cover crops, you can suppress weed pressure, also break pest cycles. And we saw a little bit about pest cycles when we looked at our crop rotations. Also minimizing soil compaction. There are cover crops that can be used if there is evidence of soil compaction, especially in the upper 6 inches or so of the soil. So here's an example of some photographs of what cover crops might look like. The cover crop down here in the bottom left-hand corner is a tillage radish. This is an example of a type of cover crop that can be used to break up soil compaction. As there's also physical properties that can be used to break up soil compaction at the surface, but this is an example of a cover crop. But this is what it would look like kind of over the fall, keeping that soil covered. So residue management and tillage management, either from a no-till perspective, which we'll look at first, or from a reduced till perspective, basically limits the soil disturbance, managing the amount, but also the orientation and distribution of crop and plant residue on the soil surface, keeping the soil covered. Again, distributing the plant residue and the plant cover allows for reduction of soil loss, reducing the velocity of that surface runoff, and again, maintaining your soil health, adjusting that resource concern. But we have some unique pieces here. We look back again, we can see what we saw similar to our crop rotation. There's opportunities here to provide food, but also cover for certain wildlife as well. So this is an example of what residue management, this is a no-till system. So you can see that the residue in the center here is very well distributed. It's kind of evenly covering the soil surface. It's also relatively large, both in width and length, which means that it's going to be able to resist rainfall impact and not wash away with surface runoff, but instead protect the soil from rainfall impact, protecting it from detachment and ultimately erosion, and also reducing that surface runoff velocity. So you can also have residue and tillage management in reduced till systems where no-till is not being used, and it has very similar purposes. Again, managing the amount, orientation, and distribution of that crop and plant residue. And again, this is year-round. And we see very similar purposes as we saw for the residue and tillage management under the no-till. So if we look at some images of the reduced tillage, you can see that it looks a little bit different. We still have that residue in between the rows here, but you can see it's much less. It's still evenly distributed. There's still very good coverage. The size of the residue is still adequate to intercept rainfall impact, reduce that detachment and ultimately erosion, as well as control the velocity of the surface runoff, but it's just not, the soil surface is not as covered, uniformly covered as it was with the no-till. And that's just because there's increased disturbance, right? But there's still benefits to meet those purposes of reducing erosion. So nutrient management, and some of you may be working through the Act 38 program or working with manure management planning, but nutrient management is important for addressing resource concerns. It looks at managing the rate, the source, the placement, as well as the timing of nutrients and possibly other amendments so that it meets the needs of the crop, which reduces the potential environmental impacts. So here we're very much looking at improving plant health, plant productivity, reducing emissions in many cases when we look at nitrogen and the potential for nitrogen to volatilize, but also controlling or addressing excess nutrients that may enter the surface or groundwater, looking at reducing potentials for pathogens from reaching the surface water, and also improving or maintaining soil organic matter. So there are some different purposes as we move into nutrient management, especially around emissions, because nitrogen will volatilize as part of the nitrogen cycle and be released into the air. But we still have some very similar purposes around improving and maintaining plant health and productivity, and looking at some of these soil properties, which is to improve and maintain soil organic matter. So some images around nutrient management and some pieces that are important when we discuss those. This is an example of spreading manure, calibrating manure spreaders, so the rate of manure in this case that's being applied, and therefore the amount of nitrogen, phosphorus, and potassium being applied. Using the analysis that's available for fertilizers, soil testing, understanding the status of the soil that's being managed and its ability to provide nutrients and how it needs to be managed from a nutrient perspective. And then also the opportunity for in-season testing, such as chlorophyll meter testing, to see what the nitrogen status is, PSNT testing, freeze-hydrous nitrogen testing, to see the nutrient status in season of different crops and how that may need to be supplemented. So nutrient management offers a lot of opportunities to understand the nutrient status, to manage our agronomic production, but there are also a few other practices that we'll look at that help to manage sometimes runoff, the associated suspended solids, which is your soil, as well as the nutrients that can come from fields that are managed for agronomic production. So a filter strip is basically a strip or an area that has herbaceous vegetation. This particular strip has specified or designed widths in order to be a strip that removes nutrients or possibly suspended solids or soil from surface water that's entering it. So there are design standards for the filter strip in terms of the width, but the intention of or purpose of the filter strip is to remove any sediment associated nutrients that may be leaving a field in a near stream area, so that you're kind of mitigating or controlling the amount of soil and associated nutrients that are entering that resource. So it's interesting, this one also has the potential for irrigation water as well. We don't see a lot of irrigation in Pennsylvania. There is some in New Jersey, but out in the West and in the Midwest, a lot of agronomic and agricultural production, and some of you may be familiar with these production systems, rely on irrigation for their production. So these types of filter strips are often used in irrigated systems as well. It's just kind of a unique piece. Won't really see that too much in Pennsylvania. So this is what a filter strip looks like. In this right-hand picture here, here's the tree line. This would be the area where the stream is. Here's your filter strip, and here's your agronomic crop field. So they're usually right adjacent to the crop fields, again, having different designed widths depending on what type of resource concern is being addressed. Is the concern controlling soil loss before it enters the field or sediment, or is the concern addressing both nutrients as well as soil before it enters the surface water? A grass waterway is another practice that you'll frequently see in crop fields. It is shaped as well as graded channel that is vegetated, sometimes rock lined, but typically vegetated, and it conveys surface water and broadens, and kind of spreads out or broadens the water so it's shallow, and then it outlets into a stable outlet. And this is really a practice that can be used in combination with terraces and diversions to control water concentrations. It prevents that gully formation that we saw on the first slide, that gully, the soil loss that can result in a gully, that very deep incised formation in a field. And it also can improve and protect water quality. So this is some illustrations of a grass waterway as it's being designed. And then up here in the upper left, it moves through its different design life cycle. And then ultimately, this is the grass waterway. And again, this is often a practice that is used with other practices that we'll look at here, combined with other practices to address gully erosion and prevent gullies from forming from concentrated flow pathways. This is in some other photographs. This is a rock-lined, waterway as opposed to a vegetated waterway. So a diversion is used also as a channel. It is a constructed channel. It is typically constructed across the slope, and it has a ridge on the lower side. This practice, a diversion, can also be used to break up concentrations of water flow, typically on very long slopes, very long uniform slopes. It breaks up the slope length. Anybody who's taken Russell can be used for that. But it can also be used to divert water away from structures such as farmsteads, agricultural waste systems, manure storages. It can collect water, and it can protect other systems such as terrace systems, other best management practice systems, so that the surface runoff is controlled as it moves into those systems. So one system that a diversion is used to control is a terrace. So terraces are earthen embankments, which are kind of a combination of ridge and channels, again, constructed across the field. You can see here in the bottom left, this is an example of a terrace system. Here's the ridge where they're farming across the system. Down here is another example of a terrace system. And this system is used to reduce erosion, trap sediment, but also manage runoff. And sometimes a diversion is used above a terrace system or can be used above a terrace system to control the runoff coming into that terrace system. There's also water and sediment control basins. These are designed embankments, or it can be also a ridge and channel, again, across the slope. And it is basically designed to reduce gully erosion. Again, we're looking at concentrated flow here as opposed to some of the other practices we looked at earlier, such as crop rotations, contour farming, that are really looking at controlling that sheet and rill erosion. So these are practices that can be used for that concentrated flow. And this is just an example of what those systems look like when they're implemented. Over here, you can see, looks like there's a standpipe in that particular image as well. So there are a variety of different types of practices that can be used. Sometimes they're used in combination. We saw that kind of with our contour farming, our strip cropping, as well as our crop rotation. And those particular practices are often focused. Their purpose is focused on erosion control, but often sheet and rill erosion control. But then we have other practices such as grass waterways, specifically diversions and terraces, which can be used in combination to control erosion and nutrient loss, but it's often gully erosion. So more of that concentrated flow control. So you can see these practices in combination across farms in Pennsylvania. They all have purposes, often design standards through NRCS. So it's a really interesting part of conservation or ag E&S planning, being able to kind of evaluate the land, identify, working with the landowner, those resource concerns as well as management goals, and then working to match different practices or systems of practices to meet those goals in your planning. So not sure if there's time for questions, but if there is, I'm happy to answer those. I will also be in the meeting this morning, so if there's questions later on, I can address those.
Great, thank you, Jen. Any questions at this time? All right, thank you very much. Up next, we have Jenny Christ, who's going to give us an introduction to livestock. You're all set, Jenny.
Awesome. My internet like cut out for a second there, so sorry about that, everyone. If you are awake and drinking coffee or tea or some other wonderful beverage, let us know in the chat that you're still here this morning. Apparently no one's awake this morning, so that's cool. Oh, good. We got one woohoo and some coffees. Good. Coffee is life. If you know me, you know that. So that's a fun fact for the day. All right, I'm going to get started on Introduction to Livestock. I am an extension educator with the Center for Ag Conservation Assistance Training. Some of you probably know who I am and have seen me present other times, but let's get started. So what is livestock? One of my favorite things to do is to look up definitions of things and see how different people define things differently. So, Merriam-Webster, that traditional dictionary says livestock are animals kept or raised for pasture or pleasure, which I really like that because sometimes livestock are more like pets or companions than they are actual work animals. So that's something to think about. And, Cambridge Dictionary also says it can be animals or birds. And really, I think we consider birds animals, but sometimes people define them separately that are kept on farms. And, some people say that the term livestock is when they are used on a farm. And so in this situation, poultry would not be considered livestock. And so I think that's a really weird thing that sometimes poultry is not considered livestock. So anyways, you get the point. I did like this definition from the Federal Motor Carriers Safety Administration because it actually talks about things that we might not consider typical livestock, like elk, reindeer, bison, live fish, crawfish, things like that, that we may not consider as typical livestock here in the United States. And so I have found this Wikipedia definition to really kind of sum it all up. So domesticated animals raised in an agricultural setting, they normally are used to produce some sort of product for consumption, whether that's meat, eggs, milk, fur, leather, or wool. And they can include ruminants, cattle, sheep, goats, horses, poultry, veal, etc. So livestock is very diverse, and it's really about how you want to define it. So livestock are domesticated animals used for production of goods and services. And here in Pennsylvania, these are our typical examples of livestock. We have cattle, both beef and dairy, goats, horses, poultry, which includes a large variety of different birds, sheep, and swine. So my question to you is, what other types of livestock are raised in Pennsylvania? Have you come across anything that's different or unique? Bison, yeah, I've definitely heard of bison. Thank you, Brittany, for putting that in the chat. Oh, honeybees, that's a good one. I didn't think about honeybees. And trout and elk both are very good. So I used to work in the Cambria County as a conservation professional, and I did nutrient management there. And there was actually mink farms at one point that were certified, that were concentrated animal operations. So they had certified Act 38 nutrient management plans. So mink are another one. So yes, all good examples. Great. So wildlife, again, or not wildlife, livestock can be really anything that we are raising domesticated and in some sort of commercial production. So beef cattle, our main uses for beef cattle, of course, are meat, but then also hide. So thinking about leather and suede, that typically comes from our cattle. And then there are a variety of byproducts that come from cattle. And so, and just as a fun note, I love to let people know that beef meat is naturally gluten-free. So if you are, if you are somebody that cannot have gluten, thank goodness you can still have beef if you like to partake in that. But byproducts, so there's a variety of different byproducts. This chart came from the Pennsylvania Beef Council website, and you can see that there's so many different things that we use cattle for, not just for their meat. But when we're talking about beef cattle, they are ruminants. So that means what? Anybody know how many compartments are in a ruminant's digestive system? Good. We got 1-4 in there, so that's great. So our ruminants consist of the rumen, the reticulum, the omasum, and the abomasum. So it's a 4-part system, which makes the cattle very efficient at digesting grass. And so cattle only have lower teeth in the front, and then their top is a tough dental pad. And so I used to work on a dairy farm, and the calves would like to suck on you, and it never hurt because they didn't have top and bottom teeth. They just have bottom teeth. So they use their tongue to swipe and bring that grass into their mouth. And cattle are going to do best when the grass is 6 to 10 inches tall. And we will see that intake will decrease when the grass height and density is decreased. So they like that 6 to 10 inches tall because they just can't get close to the ground because they're using their tongue to bring the grass into their mouth. So with beef, we have a variety of different animal types. So we're going to start out with a calf. A calf is the word used to describe a baby animal. Typically, they're going to be 0 to 8 months. And then we have what is classified as finishing. So steers or heifers could be considered finishing animals. So these are animals that are going to be raised ultimately for slaughter for meat. And so a steer is a bull that has been castrated, and a heifer is just a female that isn't going to be bred, that she is going to be sent off for meat. And then replacement heifers can range in age from 8 months to 2 years, depending on how old they are until they are bred. And then once that heifer has a baby, she is considered a cow, which I know a cow is the general term we use for cattle, but a cow is technically a female cattle. And then a bull, of course, is the male. And so you can see the standard weights there. They come from Agronomy Facts 54, and I'll talk about that at the end of this whole presentation. So some additional terms for beef cattle, because there are a lot of terms out there, and some people will use words that mean something different. Some people will throw out words that you maybe have never heard of. So feeders are going to be very much like finishing cattle, except they're going to be a little bit younger. And so they are basically on the operation to eat and grow. And they're normally in that like 8 months to like a year and a half range. A cow-calf pair is going to be when we have females. So we have cows out there that have babies attached to them. I'm going to use my air quotes because they're not actually physically attached to them, right? But they're caring for their babies. They're still nursing their young. So we would consider that a cow-calf pair. Wean is the word we use when we are taking babies, we're separating babies from their moms. We are getting them off of milk and straight onto only dry feed. A crossbred would be a term used for mixing different types of beef cattle, so different breeds of beef cattle, or even mixing a dairy breed and a beef breed together. So we'll use that word crossbred. Grass-fed is going to be a term used in the industry to describe an animal that's been fed grass its whole life. So it was born on pasture and it pretty much consumed grass its whole life until it went to slaughter to market. And then grass-finished is going to be something that maybe started out on some grain and ultimately then ended its last so many months of its life on grass. And then feedlot is going to be a term that we use for when livestock don't have access to pasture. They are outside normally and they do get exercise and fresh air, but they're not getting any of their nutrition from pasture. They're getting it all from dry hay and supplemental feed. So I have a question. How many cows does it take to supply the NFL with enough leather for a season's worth of footballs? Anybody got any guesses? Nice. 742 and 40. Those are very good guesses, but you are so far off. It takes 3,000 cows to supply enough leather for all of the footballs that the NFL uses. 3,000. That's a lot of animals, hides that are being used to make footballs. So I was kind of amazed by that. And I thought I'd just throw that in there so you could say maybe you learned something today. Hopefully you learned more than this, but this is a fun fact for you. So moving on, let's talk about dairy cattle. So our main uses, of course, with dairy cattle are going to be milk, but also veal and then meat. So dairy meat is actually, pretty popular because what happens when the cow no longer is making milk, right? Think about that a little bit. So our dairy cattle, of course, are going to have the same anatomy as our beef cattle, though typically their body type is going to be a little bit taller and leaner than beef. Now, there are some shorter breeds of dairy cattle, but if you compare them to shorter breeds of beef stock, they're still taller and leaner, if that makes sense. So we've just got a little bit more of a streamlined body that's used for producing milk. And so dairy cattle weight is going to range dramatically from the larger breeds like the Holsteins, so that's the black and white cows, and the brown Swiss. And then when we get into the Guernseys and the Ayrshires, they're a little bit more of a brown and white combination. They're in the more of the middle range for weights, and then our shortest and smallest dairy cows are going to be the Jerseys. So you can see here, I realize these are not the same people in these pictures, but an average person's height, you can see how much shorter the Jerseys are than that Guernsey Ayrshire and on the left-hand side. So some key terms with dairy that you will hear. So a tie stall is going to be a barn where the cows are tied into a stall. They each have their own individual stall and they are tied into it. Normally they have some sort of collar on and a chain, something that's keeping them in their individual stall. Tie stalls, I think, are becoming a little bit a thing of the past as, we are growing and expanding our businesses and improving agriculture. Tie stalls are maybe becoming a little bit of a thing of the past because they are very labor intensive. And so a free stall is going to be when the cows are in larger groups. They are free to move throughout that stall. They can go and lay down. They can go eat. They can eat from any of the headlocks that they choose to eat in. They have, water, everything. So they have a little bit more movement. A first calf heifer is going to be a term that's used to describe a cow that's in her first lactation. So a lactation, I didn't even think to add lactation to my list. So lactation is the word used to describe that time that she is producing milk. So whenever she is producing milk for the first time, she would be considered a first calf heifer. And AI, right? We're hearing about AI all the time, and it just confuses my brain because to me, AI stands for artificial insemination. So the majority of dairy cattle are bred artificially through AI, artificial insemination. So you may hear that term used on a farm, and that's also what ET is. It's not extraterrestrial. It actually stands for embryo transfer, because when we have high producing cattle, sometimes it's actually better to get her synced up and she'll produce a variety of embryos, and then they will take those embryos from her and put them into cows that maybe are less high producing but maybe good mothers. So there's some options there. And then milking parlor, that's what that picture shows. So that's going to be the terms that we use to describe the area where milking is occurring. We're going to call that the milking parlor. So can anyone tell me what term is used to describe a dairy animal that just had a calf? Yeah, good job, Ashley. So freshened or fresh. You'll hear farmers saying about a fresh cow or the fresh cows. So that means that they have had a calf recently. So they are fresh from giving birth. And then the kind of the opposite of a fresh cow would be a dry cow. So a dry cow is going to be a cow that has finished her lactation for the year, and she gets a little bit of time off while she's growing, producing another baby. And so she is no longer milking. So she is considered dry. So fresh and dry are two words that you may hear in the cattle, in livestock in general, but we tend to hear it a lot more in dairy. Great. So moving on to goats. Goats, their main uses are meat, milk, fiber, and I like to put in weed control because goats can be very effective at controlling weeds and even invasive species. And I know there are some individuals that are renting goats out to areas where there are a lot of invasive species for weed control. So that's a fun little side business with goats. So goats are ruminants, just like our cattle, but they have upper and lower teeth. And goats prefer to eat individual leaves off of plants. And they'll use their lips to help pick those individual leaves off of the plants. And goats will also eat above their heads. Cows will sometimes eat above their heads, but cows and sheep tend to want to eat closer to the ground, where goats will stand up and stretch, and you'll be able to see, you know, if there's like a tree line in a goat pasture, you'll be able to see how high the goats can stand up to reach because the leaves will be stripped from some of the trees up to their max reach. So our goat sizes range. Our dairy goats are going to be smaller than our meat goats. And we call a baby goat a kid. I always find a little ironic if you have ever been driving down the road and you see a sign that says like kids for sale. Kind of makes me laugh, but they probably mean baby goats, not their actual children. And then a doe is a female goat and a buck is a male goat. And so we use those terms interchangeably if they are meat or dairy animals. And just two other terms that I think are important, not just for goats, but for livestock in general, is the term wether. So a wether is going to be a castrated buck goat. So we use that term to describe goats and sheep that are castrated. We will call them wethers. And then polled is a term that would be used across all different types of livestock, but polled basically means that they no longer have horns. So genetically, horns have been bred out of their genetic line, so they do not have horns. So the goats in these pictures are not polled because they obviously have horns. So in your opinion, who is the goat? If you know what that word means, GOAT stands for greatest of all time. So there's been lots of conversations about who the GOAT is. And Kaylee put Simone Biles in there. Simone Biles is definitely one of those. And oh, we got Tom Brady. Anybody else? So my nieces are really into soccer. And so if you know who Lionel Messi is, he's also called the GOAT. Oh, nice, Brittany. I like that. That's a really good one. Yes. Awesome. Oh, yes, Tim. Kyle Sanderson. Gotta love Penn State wrestling. We've got NCAA championship this weekend. If you're excited for that, give me a thumbs up in the chat. Gotta love some NCAA wrestling. Yes, that's awesome. Good. So, we've got a few goats in and around us, which is awesome. So moving on to horses, of course. So horses' main uses are going to be recreation, competition, and work. So when we think about recreation, we're going to think about like trail riding and companion animals. There are a lot of horses out there that are companion animals. Competition, so it could be like cart pulling, like in this image here, or it could be traditional horse riding with a jockey on their back. And then, of course, we know that horses are used for work. We see this a lot in the plain sect community, but outside of that, others use horses definitely for work too. So talking about the anatomy of a horse. So a horse is not a ruminant, but they are a hind gut fermenter, which allows them to be able to break down the cellulose and the lignin in the grass and use it for energy, which is something that we as humans, as monogastrics, are not good at. Horses do have upper and lower teeth, and they have the ability to eat very close to the ground. And so horses will be extremely hard on pasture if they are just given free range of it. They can actually strip it down pretty much to the ground and almost pull the plant roots out because they can eat so close because of the anatomy of their mouth. With horses, we use the word horse to describe a variety of different animals that have different shapes and weights and sizes. So, thinking about miniature horses and miniature donkeys, they're going to be very small animals, maxing out at like 200 pounds. Ponies and donkeys are going to be smaller, but not quite the smallest. And we're going to see them maxing out around 600 pounds. Then we have light horses and mules that, again, are bigger animals, things that we're going to see mules a lot with the plain sect, maybe driving carts or doing work. And so they're about 1,100 pounds. And then those large draft horses, can be 1,800 pounds or more on average. So when we think about horses and donkeys and ponies, we use the word foal to describe a baby. We'll use the word weanling for when that foal is no longer consuming milk, but hasn't turned a year yet. Yearling is for 1 to 2 years. We'll say 2-year-olds for an animal that is 2 years old, and then mature would be anything over 3 years old. Some other terms with horses that you may hear. So a colt is going to be a baby boy horse. A filly is going to be a baby girl horse. A mare is going to be a mature female. A stallion would be a mature male. And then a gelding would be a castrated male, similar to a steer or a wether. So a gelding would be similar to that as a castrated male. And you may also hear the word boarding. So boarding is the term used when a horse is owned by one person, but it resides at someone else's residence. So there's barns that are boarding barns where the owner of the barn and the property actually does not own any of the horses. Those horses are owned by other people and space is rented at their facility. So how big is a hand? If you know anything about horses, horses are measured by a standard term called a hand. Does anybody know how big a hand is? Nice, Maria. Good job. So Maria nailed it. Maria must know her horses. So a hand is 4 inches. I had to look that up this morning because I did not know that answer. So now you've all learned that a hand is 4 inches. Moving on to poultry, our main uses with our poultry are going to be eggs, meat, and feathers. Poultry are considered modified monogastrics. They do not have any teeth. And so when they're on pasture, they're going to feed on insects and seeds, but they do not graze. And so they will also need supplemental feed. So poultry do not process, they cannot get a lot of energy or fuel from grass and forages. They are better off on seeds and insects and then feed grains like corn, oats, things like that. Poultry is such an umbrella term because it can describe a lot of different types of birds. So we can think about chicken layers. So layers are going to be birds that are producing eggs. They make eggs that then go into the market for us to consume or to be turned into baby chicks. A broiler is going to be chicken that is being produced for meat. And then, of course, turkeys and ducks are also considered a type of poultry. And again, their weights range so much compared to the chickens. They're obviously our turkeys and ducks are way larger. And then game birds are another option. And game birds, again, they have a variety of different sizes, because you can see here they start out at 0.26 pounds as the smallest little game birds, up to 3.75 pounds. And so we also want to think about the term chick. So a chick is going to be a baby chicken. And then we have a hen is a female and a rooster is a male. But I also have a few other words that we use sometimes to describe poultry. So we have the term pullet. So a pullet is going to be a female chicken under 12 months of age. And then a cockerel, which honestly, I don't think I've ever heard anyone use this word, but hey, I could be complete. Maybe I just don't talk to enough poultry people, but a cockerel is going to be a male chicken under 12 months of age. Then you'll hear the word capon. So a capon or a capon, depending where you're at, just like Lancaster and Lancaster, is going to be a castrated male chicken that is being used to turn into a meat chicken, something that's going to be grown for meat production. And then we may hear you may hear the words broiler or fryer. And so that's going to be a young meat bird chicken of either sex. It could be male or female, but ultimately it is going to be a meat bird that is butchered. And they're butchered around 4 to 8 weeks of age, depending on what the ultimate goals is of that broiler or fryer. And then a pullet is a young turkey before you can determine if it's a male or a female. So those are just some fun vocabulary words for you related to poultry. So what is a chicken's favorite vegetable? Guesses? I know you're all thinking really hard about what a chicken's favorite vegetable might be. Wow, chat is quiet. All right, so a chicken's favorite vegetable is an eggplant. Now, please proceed to laugh at this silly joke. Oh, a broccoli. Brianna, that's really funny. I like that so much. Thank you for that. A broccoli. That's a really good one. Great job. Moving on. Let's talk about sheep, okay? So sheep, our main uses are going to be meat, milk, wool, hair, and also sheep can be used for weed control. They're not nearly as effective as goats, but some people do like to use them for weed control because they're sheep are a little more docile. They'll stay where you put them. Goats are very curious and, sometimes will get out. So sheep can also be used for weed control. So again, sheep are ruminants, just like our cows and our goats. They do have upper and lower teeth. And then they have this interesting, in the front, they have a thin cleft lip. And that lip actually kind of parts a little bit. And it allows them to eat very close to the ground. And they will use their tongue like a cow. And they will, scoop up that grass with their tongue and then pull it into their mouth. So we classify sheep as large breed, medium breed, or small breed, and they range in, a max weight for a ram of 300 to 125, which is a big weight range. So it's important to understand the type of breed of sheep that you're working with, especially if we're trying to calculate standard weight or manure output, because it's going to vary based on the breed of sheep. And so a lamb is going to be the word used to describe a baby sheep. So anything 0 to 1 years old. A ewe is for the females and a ram is going to be for the males. And then again, a sheep that has been castrated would be considered a wether. And so some additional terms when we're thinking about sheep. So if you've ever heard of the term docking, so docking is going to be the humane shortening of the sheep tail to protect its health and its hygiene. Right? So docking is done frequently in the sheep industry to help protect with the hygiene and the health of that sheep. Again, that wether is the castrated male. The word mutton is going to be used to describe meat from a sheep that's older than 12 months. And then hair sheep are sheep that actually shed their coats naturally, and they do not need sheared like the wool sheep. So there are different species of sheep that actually have hair versus wool, and hair sheep tend to be more acclimated to a hot weather. So they are more adaptable to warmer weather than wool sheep, just because they have a lot less insulation. So they're also not going to be able to handle the cold as well, because they don't have that wool to keep them warm. Does anybody know what the word pecorino means? How fast can you Google it? It is a type of cheese, but what does it mean? What does it indicate? So you're on the right path, Kaylee. So pecorino means sheep's milk cheese. So anytime you hear of something that's called a pecorino, so you might hear of pecorino romano, that just means that that cheese is made from sheep's milk. So that's how we indicate that the cheese has come from a sheep. Moving on to swine. So swine, our main uses are going to be meat, and we call that pork, right? Of course. And then we will also use sheep for lard, and then swine for lard. And then we also use them for a variety of different byproducts similar to beef. So swine are monogastrics. Their digestive system is actually fairly similar to ours and how it works. They do have upper and lower teeth. And because of that monogastric system, they are very inefficient grazers. So they do not get much nutrition from grasses and forages. So they definitely are more adapt, and they will grow better on grains and other types of feed than they do on grasses. Pigs can have a huge range in sizes. So our nursery pigs, so those that are a little bit bigger than a baby. So once they're born, when they're born, the little babies, the baby piglets are fairly tiny, but once they get old enough to be weaned from their mother, they can be classified as a nursery pig. So that's when they go to kind of like a middle area where they are allowed to grow, get a little bit larger before then they get put into a big group where there's a lot of them all together. So a nursery pig is going to be that 13 to 57 pound range. Wean to finish is when we take that piglet and we wean it and we put it into a group, and it's going to stay in that whole group until it is full grown and ready to go. So it goes from where it was born to a wean to finish facility, and it's going to stay there for the rest of its days. Grow to finish is going to be a pig that has started out, born, went to a nursery, and then once it gets to be about 57 pounds, moves on to a grow to finish, where it then ends, the finishes out growing and then going to slaughter to market. Our gestating sow, so a sow that is pregnant, is going to weigh about 450 pounds, which is pretty big. Sows with their litters are classified as weighing 470 pounds as the standard weight. And then we have the boars, the males, that are, can weigh 450 pounds. However, when we are working with livestock, we always want to be verifying animal weights, because these are standard weights, and standard weights are not always accurate. So this boar here in this picture, this boar won the Iowa State Fair Big Boar competition in 2023. And his name is Sasquatch, which I think is very amusing. And he weighed 1,012 pounds. So that's over twice the standard weight. So this is why we want to make sure that we are verifying our animal weights, before, we write these nutrient management plans as NRCS 590 plans before we're planning anything, because these animals could potentially weigh way more than our standard weights. So some key terms with swine. You may hear the word barrow. So a barrow is a castrated male pig, just like we had a steer and a wether and a gelding, and now we have a barrow. So a barrow is a castrated male pig. A dam is going to be the female parent, and a sire is going to be that male parent. A gilt is a young female that hasn't given birth. You may hear the term farrowing. So farrowing is when when a litter of piglets is being born, we call that farrowing, just like we said freshening for a dairy cow, like she is freshening, she's having a baby. Farrowing is where we have baby pigs, is when baby pigs being born. Some swine operations will have farrowing barns, so barns that are dedicated to that birthing of the litter of pigs. And pork, I kind of touched on this in the beginning, but pork is the term that we use to describe pig meat or swine meat. So how many litters can a sow have in 1 year? And that's what it's called when she has babies, because she normally has, 8 to 20 babies, depending on the type of pig that she is. Yeah, Ashley is correct at 3 max, but typically in our production system, we could get a pig to have 3 litters in a year because her gestation is about that 4-month time frame, but we're typically aiming for 2 litters a year. That kind of keeps her healthy and happy and productive, but we're not stressing her out to that point where, having 3 litters a year is more of a stressor, and then she's going to be less productive overall. Good. So I included in every animal standard weights. And so standard weights are part of the Penn State Extension Agronomy Facts 54 spreadsheet. And this is also supplement 5 in the Act 38 technical manual. So if you're, looking for how to find those standard weights, this is where you would want to reference those. And then if you're trying to figure out manure production and average nutrients, so we always want to use an actual manure sample and a manure test on the farm when we are planning for manure applications out in the field, but sometimes we're not able to have those numbers. And so Table 1.2-10 in the agronomy guide or supplement 1 in the Act 38 technical manual do list manure production and average nutrients. So that is one place where you can find those things. And when we're thinking about livestock, there's a lot of things we want to consider. So culture, of course, some animals are viewed as workers on the farm. Some animals are viewed as companions or pets, and that's going to vary greatly across different industries, different groups of people, different ways of life. So keep those things in mind as you're out visiting farms. Livestock is a great way to use less productive land. So if we're not able to actually produce crops on that land, maybe it's too steep, it's shadowed, it's rocky, it's just not great land for growing crops. Grazing livestock is a great option. Livestock is adaptable, so we can use our livestock to, what am I looking for here? My brain has stopped at this point, but we can, modify our livestock's cycles and make them work to fit our needs. So if you want to have babies born in the spring because that's when you have forages, or you want to have babies born in the summer or in the fall, livestock are adaptable. They're also a great way to diversify your operation, someone's operation. So, you are growing crops, but then you add cattle into it, or poultry or sheep. It's a way to increase what you are producing on your operation. Of course, we want to think about manure nutrients. there are many pros and cons of manure nutrients, right? So manure nutrients are essentially free fertilizer and organic matter, which is great when you are in need of those things on your crop fields. But if you are short on acres or you have lots of manure, they can also be a detriment. And so those are just things we want to consider. Thinking about environmental impact. So livestock can be very good for the environment. They can utilize areas that are less productive. They can, they turn grass into meat, which is really essential. But also if we're allowing them to, run wild in the stream, we're allowing their manure to, run off into our water sources, our groundwater. There can be environmental impacts. And then lastly, if you're thinking about livestock and grazing or growing them, what are the market trends? So, I remember growing up hearing about certified black Angus and grass-fed beef and, free-range chickens. Those are all things that people are interested in or looking for. But also, when is lamb in high demand? When is turkey in high demand? So those are things to consider, when you're visiting a farm for whether or not those livestock, when they're going to be on that farm or not. So with that, I know there are no questions, but if you do have any, you can put them in the chat. I'll be sticking around. So thank you, Chris.
You're welcome. Thank you, Jenny. All right, up next, little schedule change here. We have Introduction to Pasture Management, and it's going to be with Leanna Dupstadt instead of Justin Brackenridge. Leanna.
Okay, how's that?
You're good.
Excellent. All right. Hi, everybody. Yeah, schedule change because I was set to be somewhere else, and then that whole schedule got changed. So I'm back to doing it like I was originally. So I'm going to do Introduction to Pasture Management. My name is Leanna Dupstadt, and I am an agronomy educator based in Bedford County. So let's just jump right into it because I've got 30 minutes to go through a large handful of stuff. So right off the bat, what is pasture? So essentially, it's land covered with grass, suitable for grazing animals. And we like this because it has a variety of different benefits. Things like improved soil nutrient content, helps with soil health, reduces erosion, which reduces potential for flooding. We can prevent invasive plants by having properly maintained grassy areas. Reduced energy use. So this is always the pros and cons of people talking about making hay versus having livestock on pasture. There's a lot less energy use involved with having livestock out on pasture than having to go out and mow and bale and store all of that and then bring it out to them. Pasture also allows us for really more of a broad diversity of plants and animals. So whenever you have other types of cropping systems, we want it all to be ready to harvest kind of at the same time. But out on a pasture, we can kind of use this in this continuous cycle. In addition to providing other things like food and recreation, we're raising livestock out on pasture, using pasture settings for agritourism type things, stuff like that. So when we're talking about pastures, it's not just the grass and the livestock out there. There are a lot of different components to kind of think of. So we're going to look at plant composition, and I won't go into that in detail because I know that there's a whole plant section that you guys will have learned about. The livestock species that Jenny just went through. We're going to have to look at fencing, gates, depending on what kind of livestock we have, how we want to move them around, how big equipment is that possibly needs to move through. We need to look at all of our different water sources that we can have, feeding areas, minerals, loafing areas. So if you've got patches of trees or where you have your minerals stored or where you normally feed them, there you may end up with some loafing areas. We can look at stabilized areas, sacrifice lots, things like that. And I'll kind of walk through a lot of these components in a little more detail. So looking specifically at those pasture spaces, so you have your main grazing area. This is where we've got vegetation year round for grazing, and I have year round in air quotes because we're in Pennsylvania and we can't quite graze 365 days out of the year as much as a lot of us would really like to. We have that winter time frame where forages have just shut down and gone dormant, and we have no new regrowth, and so you just you run out of grazing ability. But that's our main grazing area, and it may be divided into smaller paddocks for rotational grazing. Some instances we still have continuous grazing systems. You may also have a sacrifice lot. So this can be it's a short-term area where livestock are kept, and that's just during maybe during periods of bad weather. You may use it in the summertime, especially like last year we were very, very dry, and some folks brought their animals to a sacrifice area where it could get beat up a little bit more, but they could feed some supplemental forage because they didn't have any pasture left. But then they can go through and fix that area up and restore it. So like it says there, we're going to restore that area to its original condition after we've kind of beat it up. But we just temporarily needed to use that space to kind of salvage the rest of the main grazing area. And then we've got our animal concentration areas or heavy use areas. Those are those places where it's pretty much brown year round. There may be a stabilized pad underneath of there where they're kept. There's going to be a heavy concentration of nutrients there that will need to be addressed and moved and spread efficiently and environmentally. And a lot of times these areas are intentionally close to a barn or where livestock are regularly fed. So looking at matching all of these needs. So we need to look at all of these different components and make sure that they're going to work well together so that we can be as efficient as possible. So when we're looking at our different plants, so our cool season perennials are the majority of our pastures. They make up the majority of our pastures. And then we also have warm season perennials or annuals. So things like annuals are typically used for supplemental feeds. We've got our warm season and cool season annuals. We may use those in the summer or late in the fall, early in the spring to provide some supplemental feed to go with our traditional cool season perennial grasses out on pasture. Legumes would be a component of that. So legumes are any of our alfalfa, clovers, bird's foot, trefoil, things like that. And then of course our forbs, so our more woody species like bushes and shrubs that would be typically browsed on by sheep or goats and things like that. And we want to match those plants to the livestock that we happen to have and make sure that the livestock are going to, first of all, eat those plants and that they will kind of maximize their efficiency for whatever type of production we need from them. And so Jenny went through that whole list of different livestock species we may have. And then lastly, we need to be able to contain those livestock so that we can have them utilize the grasses efficiently so we can keep the livestock safe and move them where we need them to go. But we have to look at what kind of livestock we have to make sure we're picking fencing that's going to keep them contained appropriately. So things like cattle, we can typically use, we can use electric or not electric. Whenever we go to like sheep and goats and things like that, a lot of folks will start using a woven wire or a page wire. A lot of barbed wire is still used throughout Pennsylvania. So just matching all of these three things together so that we can be efficient. Watering systems are a big component and can sometimes a big hassle for farmers whenever we're talking about pasture systems. So you're either utilizing an existing water source or we're digging a new well. We can utilize surface waters like ponds or streams that are already there, making sure that we're sectioning off those so that we don't have unlimited access and we're not loafing in the water too often. Some water systems will use electric pumps. Some of them, if we have access to electricity, some of them will have solar panels involved. We may do a gravity fed. So we pump up to the highest part on a field and then gravity feed down to other troughs. This may be through lines that are dug underground, or we may have hoses running kind of with the fencing above the ground, keeping in mind that whenever we have systems like that, we have to think about the winter time and whenever we would have that freezing temperatures. And so you kind of have to, when you're thinking about water systems, think long-term and year-round and how you want to utilize that water when and where and things like that. Also looking at the size of the tanks and the amount of water that's available to make sure that we're providing adequate quantities of water to our livestock. Water intake is directly correlated with feed intake. So the more water they drink, the more feed they eat, the more production we have. So we got to keep that in mind. Also, kind of going along with these water systems is you may have these stabilized areas. And so when we're talking about stabilized areas, usually that's in places of heavy animal concentration. So around waters, around feed bunks, like you see on the bottom right, maybe where you have your mineral located. And so you either have to, so if you're going to have a permanent spot, a lot of times stabilization is the best method. But if you have the ability to move those systems around, you can maybe avoid having to put in a stabilized pad. So like the water system you see on the left there, that's a hose with a portable trough. And so if you could actually just move that further down the pasture every so often, or every time it needs filled, or every time they kind of go through a rotation in a paddock, you can maybe prevent these dirt areas by just moving those areas around the fields. Riparian buffers, not just for whenever we're talking about cropland or conventional farming, really great in pasture systems to keep animals from loafing in those surface waters. Riparian buffers, I'm sure we all know about them, but they're great at filtering runoff. Of course, we have manure deposition from our livestock, and so we want to make sure that all of that concentrated nutrients are being filtered out before they would go into any sort of waterways. Looking in Pennsylvania specifically, we've got a lot of mountains and hills. And so any way we're able to kind of slow down any flow of waters from rainfall events to capture all of that sediment and nutrients before it gets in our water systems is beneficial. Also helps with stream bank erosion. So livestock are very hard, especially larger animals like cattle and horses are really hard on those stream bank areas when they're kind of going up and down into the stream, and they break that away and cause more erosion. And they also introduce a lot of fecal bacteria into those water resources. So streams, thinking about the fact that that's all going to flow downstream to anybody else. And for ponds, thinking about the fact that that water may not flow through very quickly. And so you have a lot of that fecal bacteria or any bacteria load or any high nutrient quantities in those ponds. And so then your livestock are still trying to drink from that water source, and that may cause some health issues down the road. All right, so starting to look specifically at the grazing portion of this. So some of our the strategies here with grazing. So when we're talking about managed grazing that I have highlighted there at the bottom, we're wanting to maintain an optimum sward height. And that's both good for, Jenny talked about the way that livestock eat and how they prefer to eat, like cattle like to eat forages that are much taller. But that's also really beneficial for the grasses themselves. So we don't want to overgraze our pastures, because then we start to decrease the longevity of those grasses. So for grasses, most of them store their nutrients in the lower portion of the stem. And then other things like our legumes, so those clovers and alfalfas, they store nutrients in a crown that is at or below surface level. So you have to think about that whenever you're going through and grazing, to make sure that you're not overgrazing your grasses, because you're depleting their nutrient reserves constantly, and they won't be able to bounce back very well. So formal definition of managed grazing, basically just controlling when and where our livestock are going to be consuming pasture. And we want to do this so that we reduce that selective grazing, that aggressive grazing pressure. It also helps us with manure distribution, parasite reduction. It can also allow us to increase our stocking rates and carrying capacity, and I have a slide on that later, and improve that stand longevity that I was talking about. So building soil organic matter. So the ability to make sure we always kind of have this good ground cover. We're not overgrazing. We're getting good, even manure distribution. It allows us to maintain that root mass that you can see in this image here. whenever we have higher amounts of forages too, it reduces that runoff. It helps us to capture more nutrients, keep it there on the pasture where we want it to be, because it helps us so that we can have this kind of constant regrowth and cycling of nutrients, but also for environmental reasons. And having that organic matter increases our water holding capacity. And so we're able to capture even more water and helps to reduce a lot of wet and muddy areas that we might see. So here's what I'm talking about with some of those benefits of managed grazing. So if you were to look at this laser pointer, so these are residue heights. So meaning that I left behind 6 inches of forage when I grazed before I moved them to the next paddock. And right here, I left 3 inches, and here 1.5 inches. And so what I want you to look at is, first of all, this number of grazing events that you were able to have through the year. Is once you started getting down to that 1.5, we were only able to get 4 grazing events out of that compared to 6 whenever we left 3 or 6 inches. And then moving down to the end here in pounds per acre of how much we were able to get. However, so it looks like here, you're able to get more pounds of forage per acre out of this 1.5 inch. Yes. However, if you actually do the math here on how many pounds per acre and how many grazing events you were able to get, you can see here that we were actually able to get less than if we were to hit that like kind of 3 to 4 inch height that we typically recommend for our grazing, minimum grazing heights to leave behind. And when our 6 here, we were only actually able to get 4,500 pounds total for that grazing season. So you can see here that we're really trying to maximize the amount of quantity we're able to get. So it may seem like, oh, I'm grazing more of that pasture, but you're doing more harm than good. And so this video here really shows that well. So this is from the University of Kentucky. This is orchard grass, where it was grazed to 1 inch on the left and 3.5 inches on the right-hand side. And this is just 5 days of growth. And you can see just how much faster the one on the right is able to regrow after a grazing event because we left more stubble height behind. We left more nutrient reserves. We also left more green surface area for photosynthetic activity. So it was able to photosynthesize rather than just trying to live off of stored nutrients. And this was something too, we were really trying to hammer hard in a year like last year. We've had a lot of conversations about during a drought year and the ability of these grasses to recuperate after a drought. And so you can imagine we kind of shut down with our grass growth there in the summer. You can imagine how much easier the grass on the right would bounce back once we started to get rain compared to that one on the left. And we did actually see a lot of overgrazed areas where those grasses did actually die. They ran out of nutrients and they ended up dying rather than being able to remain dormant during that dry period. Some other benefits of grazing. So we talk a lot about this with hay production, but the same principle applies to grazing. It's just maybe sometimes a little bit easier in hay because you can really watch it and monitor and you get this straight cut across. So we have to be a little more aware during our grazing. So what we're looking at here is just the growth of our grasses from early vegetative all the way up to whenever they have a seed head on them. So we're always trying to maximize quantity. So the further over here we can get, of course, the more grass is there. However, you can see with these 2 lines, so this is protein, which is what we look at a lot for quality. This protein starts to decline as our grasses mature. So where those lines intersect here, where we can maximize on our dry matter and maximize on our protein right here, is usually where we want to be able to graze those. So if we can graze at that period of time, we'll maximize the amount of forage we can get, maximize the quality. And so what we want to pay attention to as well is if we've got some high producing dairy cows that we're out there rotating twice a day, once a day, they're always kind of getting this really early stuff and just getting right off the top here. And so that's really high quality stuff. Whereas for other livestock, we're maybe leaving them in there for 3, 5, 7 days, they're getting all the way down to that 3 to 4 inch height. So they're getting a little bit lower quality, but they don't need that top-notch quality like our dairy producers do. So our different types of managed grazing, continuous is that kind of traditional way where you've got livestock in a pasture with a fence around the outside, and they're allowed to be in that space 24/7. At some point in time, maybe in the spring, some producers would maybe take off a section for hay or segregate off a section because there's surplus forage, they didn't need it, and they would use that for hay production. Rotational grazing, that's whenever we start to any point in time we start to subdivide the pasture into smaller spaces. So a setup like this is very simple, where we still have our exterior fencing. We've put maybe this one down here is a permanent fence straight down the middle, and these ones running across horizontally might be temporary. And so we're able to just kind of rotate the cattle around like this, allowing these paddocks over here to rest while they're grazing other areas. And that's really the key there to any sort of managed grazing, is pasture rest. Strip grazing is another term that you might hear most often used when we're grazing annuals or stockpiled forages. So for grazing something like warm season annuals, think of Sudan grass, sorghum Sudan, something like that. We would strip graze those. So we would have an exterior fencing, and then we would just put in some temporary fencing. And so they would graze one section at a time. We would do the same thing if we were doing stockpiling. So stockpiling is whenever you save up on some of your pasture to be able to graze it during the fall into winter. And so stockpiling is just anytime you're kind of saving a forage to graze for later in the year. We would do a similar scenario. If we wanted to go circle back and regraze this area again, because there would be some regrowth, we would want to make sure we're doing back fencing like you see here. So this is our front fence because the cattle are moving from left to right. This is our front fence, and back behind them is a back fence. And we would use that, like I said, if we wanted to graze this area again and we don't want the cattle to go back. Or any livestock. Livestock like to graze those fresh new shoots, and so they would very quickly realize that this was nice tender growth back here and keep circling back to graze those areas, and we would want to prevent that. So something to keep in mind, we often have this trouble when you're kind of talking with someone on how to set up a grazing plan, is that we don't have to have square pastures. So simplest thing to do, split a pasture in half. So now we have two sides. One side still gets a chance to rest, which is great. But whenever you have a water source that's kind of stuck off here to the side, people get concerned on how they want to divide this up. And they don't have to be square. So you can do kind of like a wagon wheel style of sectioning. I usually recommend it. It's easier if you keep these spaces at least the same acreage. That way you have an idea of how much forage is in there and you can keep better track of it. So making them the same size. But overall here, the goal is just pasture rest to aid in pasture persistence and making sure we're providing some high quality forages for grazing. Some other things to think about when you're setting up a rotational system is the fencing component that we talked about. Think about where the water is going to be. Maybe you have a water source in the center. That's great. So it's very easy to just subdivide into 4 sections. You want to think about the movement of animals. So if you had a continuous system and you see that there's a very clear walking path of dirt where the livestock go up and down through a field, you want to keep that in mind, because creatures of habit, they're still going to want to walk in that area. So think about where alleyways and laneways should be, where a sacrifice lot should be, easy access to get to those things. Thinking about paddock sizes, how many livestock you have, how often you want to go through a rotation. A lot of times we say a 4-to-1 ratio maximum, because if you look at this here, these sections are both 64 square feet. However, this one is going to require 40 feet of fence, and this one is going to require 68 feet of fence. And if you think about the cost of fencing right now, it's very high. It's gone down a little, but still very high. And so anything you can do to kind of keep those costs down and keep this 4-to-1 ratio is best. And also there's the ability to use temporary fencing. So maybe the entire interior is nothing but temporary fencing, and that's okay. So we kind of talked about this a little bit earlier, but that's that target grazing. So trying to eliminate any of that spot grazing or these heavy use areas like around a water in the field. So move water sources if you can. Definitely keep water sources away from gates, because gates themselves are also heavy loafing areas, especially livestock that are used to a rotational system. They'll be ready to move to the next paddock, and a gate will end up being a loafing area. You can do the same thing with feed bunks, mineral feeders, move them to less utilized areas of the field, just to kind of force them and draw them into those spaces to start munching on those grasses down there. You could also start to decrease paddock sizes, because then the smaller space they have, they'll utilize that whole space. That being said, then you have to usually start rotating more often. And so from a management perspective, that can sometimes be a little more difficult. So here's that target grazing that I was talking about. Sorry, I forgot that there was a slight animation. So that's a feed bunk being moved around. So the livestock will most likely want to loaf up here near the water in this shade tree, particularly on a hot day. But if you kind of drew them down here with either this is a feed bunk or a mineral tub to kind of move them into those less utilized areas. Also helps with even manure distribution as well, because a lot of manure deposition would occur over here. So trying to force it into this area. If you had the ability to move the water away from this tree, that would also be a really good option. Maintaining optimum stocking rates. We don't want to overgraze our pastures. We kind of had a whole discussion on that, so I won't labor on it too much more. Trying to eliminate that spot grazing, underutilization of pastures, eliminate any bare spots, because you'll start to have thinning, weeds will start to creep in. But you also don't want to have an undergrazed scenario either, because the exact same thing can kind of happen. Some unwanted species can still start to creep in over time. So some common grazing mistakes: grazing pastures too close, stunting that growth, rotating animals too quickly, so not allowing pastures to have enough rest time and time to regrow. Also removing interior fences to allow animals to clean up pastures. We see this most often in the fall, whenever we're kind of starting to run short on our pastures, and so they'll just open up all the gates and basically have a continuous grazing system again. But we don't want to do that, because then we're stunting those grasses, and we want them to have a good residue height and some good nutrient storage so that we can have survivability over the winter months. We don't want to ding them up too much before it starts to get cold. Some things to think about from a management perspective: those pinch points, like I said, alleyways, gates. Anytime we're entering barns or paddocks, a lot of times we'll have issues with mud here, where we can have concerns with livestock health, especially smaller livestock, cow-calf concerns. This becomes an issue whenever we have muddy livestock, and also resource concerns, because now we have the potential for a lot of this soil. If a heavy rainfall that comes in, the snow starts to melt very quickly, that water being able to pull that off the farm. Management things to consider: so overseeding pastures. We may do this anytime that they're looking a little bit thin. We can broadcast, or we can frost seed. So frost seeding is something that we would do during that period of freeze thaw, which some parts of Pennsylvania are actually still going through right now. It was 26 degrees where I am, and it's going to get up to the 60s today. But it's that point in time where overnight temperatures are below freezing, daytime temperatures are above freezing. That's that frost seeding time frame. And we would do that with a lot of our small seeded species, because they would fall and be pulled into the soil very easily. For other species, we would use things like a no-till drill to just come through and try and thicken a stand. Some species better suited than others, and that's a whole different conversation. Grasses will not always fill in those thin or bare areas, because we may not have proper fertility or pH. And so that's a whole nother component, is we still want to pay attention to pasture fertility. It's not a 1-to-1 ratio where we've got livestock consuming that, it comes out the back end and is reapplied to the fields. So pastures can be a really top producing crop on the farm, but we're not always thinking about them as a crop because we're not growing them that way. But it should be treated that way still. So we want to make sure we do soil tests, make sure we're not doing over applications, which could be really expensive and also an environmental hazard and just more work in general. But we don't want to under apply either because we're going to diminish our growth. We're not going to have good stand persistence. We're not going to get the forages that we want. And so we're not going to have the livestock gains that we want. So here's just a very simple graphic of our soil samples. And this comes into play a lot with pastures because you want to avoid those oddball areas. So maybe this corner here is where a water system is, and we've got a lot of loafing, a lot of bare area, a lot of manure deposition. We want to avoid that. We want to get the bulk of what our pasture is, and so we would kind of go through this white area here. If we want to sample these, we would sample them separately so that we can make sure we're not under applying in these areas and over applying in these already nutrient dense areas. So here's a nice image of what that manure distribution looks like. So kind of that image I showed with the water and the tree and the bunk being moved around. So down here on the bottom, you can see our waterers. And up here at the top, you can see we have trees. And you can just see the piles per 500 square feet. That's how this table works. It's just so many more manure piles here around the waterer and around this tree. So like I said, if we could move these waterers to different areas, even if we were able to just move it up to here using a hose or something like that, to get a nice even distribution of nutrients. So like I said, pasture fertility, not a closed loop system. About 80% of the nutrients that are taken by the animal, ingested, are put back onto the pasture through manure. This can be higher if outside feed is brought in. So if you are providing any sort of supplemental grain, the minerals that are brought in aid with this. Hay that is fed on pasture. Bale grazing can add an even higher component to that because there's some feed left behind to kind of go back into the soil that's not consumed by the livestock. So another thing that you can do is an incorporation of legumes. They help provide nitrogen. At least 30% of the pasture needs to be legumes to provide that nitrogen component to the grasses. They also need to be properly inoculated. And then species selection is a big component of pasture management as well. So wrapping it up here just quickly with weed management. So for every 1 pound of weeds present in pastures, those desirable forages, those grasses that we really want to be there, are reduced sometimes by up to 2 pounds. And so you're losing a lot of space and availability to be able to grow your forages whenever weeds start to creep in. Overgrazing is often a problem that causes this to happen. Selective defoliation because they're allowed to go through and just graze what they want. They'll leave behind those more stemmy things. They'll leave behind a lot of those weeds that are there. And just over time, they're able to creep in. So the solution here is that managed grazing. You can see in this continuous image, a lot of the weeds are still left behind here. And they've also got some selective grazing. You can see areas where it's much shorter as compared to this rotational system here. So the cattle are back here. We're about to move them over into this next paddock, but just see how much more evenly grazed this is, less weed pressure. And so that'll definitely help with that. Here's some more visual observations where you can see this is a continuous system where we've got overgrazing and weed pressure coming in. And something else that what we were able to see with this was some research that was done up at the university. So this is a continuous system here. We sampled 3 times throughout the year. Here's the rotational system and their 3 sample times. We were able to see weeds actually start to decrease in a rotational system. They kind of maintained themselves in a continuous system, but we definitely saw a higher incidence of weeds during the middle of the summer when our cool season perennials had really slowed down because it was too warm for them. And so weeds started to creep in a little bit in the middle of the year. Some other things we saw were things like orchard grass actually started to increase with our rotational grazing systems, which is great because that's one of our desirable forages. Whereas it actually started to decline in our continuous systems. We were overgrazing it and it was starting to die back. Some other methods for weed control, mechanical, which can be limited efficiently. Whenever we're talking about pasture systems, going through and hand pulling weeds can be tedious, especially depending on how much pasture space you have. Mowing can be something that you can utilize, targeting the annual species specifically, and spraying is a component as well. So, but proper weed identification for that is key to make sure we're selecting the appropriate product. And so things like the agronomy guide can definitely help us with things like that. And in summary here, so the goal with pasture management is healthy, productive forages that can provide quality feed for our livestock. We want to maintain or improve animal productivity. We want those grasses to persist for multiple years. They're perennial. We would like them to be there as long as we can utilize them and not have to reseed annually. We want this to require less inputs. So rather than doing hay production, we want to be able to have our livestock harvest our forages for us. Less inputs, less overall costs. If we're managing it appropriately, we may need less fertilizer, herbicides, overseeding, things like that. We want to still keep an eye on those things, but we can definitely really reduce those inputs. And there's never a one size fits all solution. So that'll be that's the fun part to me anyway, whenever you're working with each individual producer, is asking them what their management goals are and their management style and how they want this to work for them and what they want out of their livestock and economics and all that good stuff. So putting it all together to meet the needs of each individual producer and how they want things to go. So with that, if there's time for questions, otherwise I will hang on here for a little bit and I can answer questions in the chat.
Leanna will also be at boot camp for a day next week, so we have that opportunity as well.
Yep.
All right, great. Thank you, Leanna.
Sure.
Okay, so we're going to take about a 15-minute break. Everybody can stretch and refresh their coffee or yerba mate or whatever else you might be drinking this morning. We'll see you back here in about 15 minutes. All right, welcome back. Hopefully everybody got a chance to stretch and walk around or answer some phone calls. Tim, are you there with any wit or witticisms today? Maybe not. All right, well, I have some wisdom for you all this morning, and then I'll pass it over to Jenny to talk about biosecurity best practices for farm visits. But I just wanted to let you all know that time flies like an arrow and fruit flies like a banana. So Jenny, with that, take it away.
Thanks, Chris. Welcome back, everyone. I'm going to cover biosecurity best practices for farm visits. I have a feeling you've been hearing a lot about biosecurity, but hopefully we can just reiterate some of those things you already know. And then if there are any questions, feel free to put them in the chat as I go along. So I have divided this really into 3 sections, like before you arrive at the farm, while you're at the farm, and then as you're getting ready to leave the farm. So before you arrive at the farm, you want to first, call and have a conversation with the farmer or the operator and find out what their opinion or their view or their policy is on biosecurity. Some operations will have written biosecurity policies. They will have steps that you have to follow if you are coming onto their operation. So you want to call and discuss those things with the farmer or operator prior to going out on that farm visit. You want to ask them the questions about, like, where should you park? What types of precautions would they like you to make? Is there anything that they're concerned about on their operation? Those are things that would be helpful to know so that you can plan appropriately for that farm visit. So you want to make sure to try and schedule farm visits with downtime in between. If you're going to I would recommend if you're going to a poultry or a dairy operation to try and plan that either towards the end of the week, like a Thursday, Friday, where then you can avoid, visiting any of those types of farms for the next few days, including that weekend. So a good 48 to 72 hours in between farm visits. You also, may want to schedule like the first beginning of the week. And if you go to a dairy operation on Monday, don't go to another dairy or another poultry operation until the end of the week. So you want to be able to plan your farm visits out and really schedule them with downtime in between. And I know that can be very challenging, but it's definitely very important, especially right now, because we have such high biosecurity concerns with the high pathogenic avian influenza, or HPAI, if you've not heard of that before. You also want to try to avoid stopping at high-risk areas. So I used to work for the Cambria County Conservation District, and there was this beautiful county lake that we would like to stop at for lunch, in between visits or events, and just enjoyed the lake. There was never very busy, and there was a nice place to sit and eat your lunch in the shade. But that lake started to get overwhelmed with wild geese. And so we all know what wild geese do when there's lots of them. They make messes everywhere. And so it became an issue because we could no longer keep ourselves and our vehicles clean whenever we would go to that county park. So try to avoid stopping at high-risk areas. So places where there may be wild birds congregating, where you might be driving or walking through their poop, try to avoid those areas. And also think about places where there might be invasive species, especially if there's, the wind's blowing and seeds are blowing with it from various invasive species. You don't want to be taking those plant seeds with you to a farm. And then, of course, you want to restock your biosecurity supplies. Biosecurity is not a linear. I have my presentation, of course, set up linearly, right, from before, during, and after. But biosecurity really is a circular process. And so as long as you are keeping up with things, then some of these before things have already been done. And so you don't have to redo them. So checking your biosecurity supplies, if you're constantly using them, then you're keeping up with what you have, so you know you have enough. But if you've not used it for a while, or if you rely on shared resources, I highly recommend, checking those supplies and restocking before going on any farm visit. And then finally, before you go, you want to make sure that all the equipment, vehicles, boots are clean and disinfected. So I think some of you probably do some land surveying. So you're using a tripod to hold the total station, or whatever the device is going to be called that we put on top of that, because I can't think of it right now. All I got is total station right now in my head. So, your survey equipment, your shovels, if you're doing soil tests, you have buckets that you collect samples in, any of that type of equipment, you want to make sure it is clean and disinfected before you go to that farm visit. And like I said, if you're doing this when you're finishing up your farm visits, then you don't have to do this before you go, because you've already done it. But if it's the first time, day of the season, maybe you forgot to do it before when you finished the last time, but make sure that all of those things are clean and disinfected before you go. So while you're at the farm, there are definitely things that you need to do. So again, I told you this is like a circle, and repetition is key with biosecurity. You want to start clean. So you want to arrive at the farm in clean clothes, with clean shoes, and a clean vehicle. And really, you have two choices when you get there. You can either scrub in, so you fill your disposable tub with water and a cleaner of some sort, and you can scrub your boots when you get there, or you can cover with disposable boot covers. So disposable boot covers are a really useful tool when visiting farms, because they're kind of easy. You just put them on and then you take them off before you leave, and then you don't have to maybe worry as much about scrubbing your boots. And again, you want to check to make sure your equipment is clean as you are pulling it out of the vehicle to go out into that field or that farm and do the things that you need to do. Again, make sure that your equipment is clean. You want to follow the farmer's biosecurity procedures when you are on the farm. You want to respect whatever the farmer has laid down, whatever their choices are for biosecurity. You want to make sure that you are following their procedures, you're respecting them and what they have decided. And then we want to move from most susceptible to least susceptible. So when we're thinking about livestock, the animals that are going to be most susceptible are going to be the young animals. So we always want to start with the young animals, and then we want to move up in age to the, teenager animals, as I'll use my air quotes, the teenager animals, then to the mature animals that are in production. And then lastly, you can head out to that animal mortality composting area, because a dead animal is not susceptible. So that would be the least susceptible. So you can head that last. So again, most susceptible to least susceptible. And that would include even thinking about field crops, pastures, anywhere where there may be plant diseases or weeds of any sort. So if you know that a field has a specific plant disease, that's the area you want to go to last. You want to go to the fields that are not infected with that disease. And then we want to avoid backtracking as much as possible. We want to try to avoid going back somewhere that we have already been. We want to just keep, progressing forward, progressing in one direction through that property around that area. We want to avoid touching animals and plants. And listen, I grew up on a farm. This is hard for me, but this is something that I've really put into practice, because we do not want to be touching animals or plants and picking up any sort of diseases, insect pests, anything like that, and taking them with us. And even thinking about like farm cats. So I have 2 cats here at my house. Yes, Chris, good. Chris knows me so well. I have 2 cats here, and cats seem to love me very much, and they will come over, but I choose not to pet the cats, because you never know what that cat may be carrying. It could have ticks, it could have fleas, it could have midges or mange or anything that you could then bring home. So again, avoid touching the animals and plants. And then of course we want to avoid those high risk areas. So high risk areas are going to be things like feed bunks, manure storages, barnyards, silage leachate areas. So anywhere where things are kind of wet, even muddy fields, can be a high risk area. So you want to try to avoid those things. Now, I understand, especially when doing some land surveying, if you're surveying for a manure storage or a heavy use area, you have to get into that barnyard. You have to go into those high risk areas. I get that. And so when you do that, you just need to make sure that after you're finished in those areas that you are disinfecting and cleaning and disinfecting your equipment. So again, I realize that sometimes we do have to go into those high risk areas, but for the most part, if we can avoid them, avoidance is the best option. Some farms will actually have an additional layer of biosecurity. They will have what we call structural biosecurity. And this can be physical barriers. So think about walls, fences, gates, and even feed troughs that really are doing two things. These walls, fences, gates, feed troughs are keeping animals in one area. So they're keeping our livestock confined to a specific space, but they're also keeping people and other things out of that area. So that physical barrier kind of does two things. It's two purpose. And then there's also something called a line of separation. So if you look at the lower picture, you can see that yellow line around that farm. So only individuals that are approved to go onto that farm are allowed to cross through those gates and actually drive onto that property. So think about, service providers, so feed service, mechanics, veterinarians, and workers. Those are the types of individuals that are going to be approved to cross into that property through that yellow line. Possibly you, if you're making a farm visit because you've reached out and you've asked. But the general public and other people like that are intended to stay outside of that yellow line. But then if you look closer, and again, I apologize because it's not the best picture, but each of those buildings is lined in red. And so that lined in red is an additional line of separation because the feed driver is allowed on the farm, but does the feed driver actually need to go into the facility where the animals are? No. And so that's an additional line of separation. Only those people approved to actually go into the facility themselves are allowed to cross that red line. And a lot of times we see these types of lines of separation in swine and poultry when we are raising those animals in those larger buildings. And to enter those buildings, which really is not something as conservation professionals we should have to do. You normally are going to be required to put on like a Tyvek suit and boots and gloves and even sometimes head coverings. And sometimes you actually have to shower in and shower out if you're going to be going into those buildings. So as conservation professionals, we really do not need to be going into those types of buildings. Veterinarians, they may go in there, that kind of thing. And again, I know I said this on the last slide, but you want to avoid high risk areas. So we want to avoid going into any of the facilities where the animals are located. We want to avoid manure, feed, silage leachate, muddy wet field areas. Those are the things that we want to avoid. So when you're getting ready to leave the farm, you want to scrub. And so when you are getting ready to depart, you need to remove all of the organic matter from your boots and your equipment with a scrub brush and a type of cleaner. So the cleaner that I have here, and again, you don't need to use this type of cleaner, but any sort of all-purpose cleaner is totally acceptable. So this is Simple Green all-purpose cleaner. I am not sponsored by Simple Green. It just happens to be what the admin purchased for me to have here on hand. And so Simple Green, all-purpose cleaner, you need to remove all of that organic matter. So grass, weeds, weed seeds, mud, manure, urine, silage, you need to remove all of that organic material. And all you really need to do, all you have to do is follow the label. So this one here, it has 3 sets of instructions for whether you need light cleaning, general cleaning, or heavy duty cleaning. So follow your label for what strength and what dilution you need for that cleaner. But use a cleaner to get all of that organic material off. And again, using a brush, a scrub brush is a really great option. Once you've removed all of that organic material, then you want to move on to the disinfecting stage. And so I highly recommend using a disinfecting wipe on things like your phone, a clipboard, and any small equipment like a camera or a clinometer, any of that hand level, any of that small equipment that you may be using that you can wipe down with a disinfecting wipe. So again, here I have these Clorox disinfecting wipes. And these here are actually considered a pesticide because they have an EPA product registration number on the back. And I am not going to show it to you because it is absolutely tiny. But the key with using these wipes is to follow the instructions. And so it says to clean the surface first before you use the wipe. So these are only effective if the surface is clean. And then you want to keep it wet for 4 minutes. So follow those instructions. The label is the law on those wipes. But I recommend using those on your phone, your clipboard, and small equipment. And again, just as a reminder, wipes are not for hands. These disinfecting wipes are not for hands. They say that specifically on the label. They are not for hands. So once you've wiped down your phone, clipboard, and your small equipment, then you want to use a disinfectant on your boots and your larger equipment. So you've already scrubbed your boots and your larger equipment with that all-purpose cleaner. And then you want to follow up with a disinfectant. And so I have here a disinfecting spray, which is an option. This is very convenient because it's portable and it sprays really easily. However, it does require a decent amount of time. It needs to sit on that product for a decent amount of time for it to actually control any of the germs, viruses, bacteria, etc., that it lists on its label. So again, this is a EPA registered pesticide. And so we want to make sure that we are following the label and the law for these products. Okay. You should always follow the law, right? But in this case, the label is the law. So make sure you follow the label. That's what I was trying to say. And then finally, once you've finished doing all of that, you want to sanitize your hands or wash with hot water and soap. I realize access to hot water and soap is not always an option. So that's why I recommend keeping some sort of hand sanitizer with you. And again, reading that label, because some of these say that you need to rub for a certain amount of time. I have 2 different ones and they have different instructions on them. So make sure you're aware what the instructions say, how long it needs to be on your hands to actually sanitize your hands. And then finally, if we did wear booties, and we used disinfecting wipes, we want to dispose of them into a trash bag. And you can either ask the farmer if you can dispose of it at the farmer's facility, or if not, take that with you and dispose of it when you get back to the office as soon as possible. Another thing you should do is ask the farmer the best place to dump your scrub water. I realize it's typically just some sort of general purpose cleaner, but ask the farmer where you should dump that scrub water. Parking lots that aren't draining into a culvert or a sewer drain of some sort, that's a great place because it will basically just evaporate. If there's an area of the grass that's not really heavily trafficked, that would be an acceptable place too. But again, ask the farmer. And if the farmer's unsure, uncomfortable, doesn't know, you can easily get a bucket. Take a bucket with you. Lowe's sells buckets. Probably lots of other places do, but Lowe's is what popped in my head. Buckets that have lids that you can snap on, so you can pour that into that bucket, put that lid on, and then take it back to the office. And again, you want to dispose of it someplace where you can allow it to air dry. So whether that's a sidewalk or a pavement that's not, again, running into a sewer or gutter or a drain of any sort, or into some grass that's a distance away from a water source. So scrubbing procedures, again, this really is very repetitive, but I sometimes think that is the key thing, is you want to mix water and cleaner according to the label. So again, you want to mix up your all-purpose cleaner according to the label's instructions with water. You want to use a brush, something that's coarse, bristle type brush. I don't have mine with me. I actually gave Chris my brush, so he has extras for boot camp next week, so you can all scrub in and scrub out appropriately. So use your brush, remove all of that organic material, so mud, manure, plant pieces, etc. Get them off of your boots and your equipment, and then disinfect your equipment either with a spray or with a wipe according to its labels, and then follow up with disinfecting your hands. I recommend when you show up to an operation, again, your equipment should be clean, right? But I recommend either scrubbing your boots or covering them with disposable booties and using hand sanitizer when you get to the operation as like a scrub in type of procedure, and then scrubbing out is the same exact thing. So with biosecurity, really the goal is to break the spread. So we want to plan downtime between our visits, at least 48 hours, if not more, is best. You want to do logistic planning based on known issues. So if you do have to go to multiple operations in one day and you can't separate out the types of operations, you want to try and go to the areas with known issues last. But again, try and schedule that downtime. Cleaning and disinfecting everything is a must, and removal of organic material really is key with our biosecurity. And so these are some good supplies to have on hand. If you have water, so I have a jug, it's a couple gallon jug that I fill with water, and I just keep that in my vehicle. Disinfectant, so something like this spray, all-purpose cleaner, something like this, a scrub brush, a tub. The tub I use is a livestock feed tub, so it's kind of rubbery, and it's not really big, but it's deep enough that you can put your foot in it and it works fairly well. Some sort of disinfecting wipes, hand sanitizer, trash bags, and disposable boots. So disposable boots you can typically get in a pack of like 25 pairs, so they do last a little while, which is really convenient. So I want to discuss a few whole farm biosecurity considerations, just things, food for thought, things to get you thinking whenever you are heading out to do a farm visit. So there are different areas of concern. I think a lot of times we focus solely on animal biosecurity. So infectious diseases and viruses and insect pests, moving from livestock to livestock, or wildlife to livestock, or livestock to wildlife is something that can happen. And so that's really what drives a lot of our talks about biosecurity. But we also should consider the plants that are on the operation, whether they have diseases or insect pests, or if the plant themselves is a noxious weed. We want to consider what's happening in the soil. Are there any plant diseases from the year before that's, hanging out in the residue? Are there nematodes? So nematodes are great sometimes, right? So we like nematodes and we hate nematodes. It depends on the type of nematode. So if you have soybean cyst nematode in your field, you really don't want to be moving that soil to another field where there is not soybean cyst nematode. Insect pests can also be moved in soil, whether the pests themselves or their eggs or their pupa, however they're overwintering, that can also be moved in the soil, and so can plant material. A lot of our noxious and invasive weeds will reproduce from just stems and leaves and pieces of plant material. They don't actually have to even be seeds. So keeping an eye on that. And then of course, water can also be a source of diseases. They can be a source of diseases that affect humans and diseases that affect plants and animals. And they can also be a harbor for pests, whether those are insect or plant pests. Water can be a harbor for that. So be cognizant of these areas when you are doing a farm visit. And so I talked a lot about biosecurity, and I have a list of resources here, and Chris is going to put each of these resources in the chat. I'm just going to give you a quick overview of what they are. So the top one there is for the extension, Penn State Extension website, and basically it is just a standard response to a query to biosecurity. So any news, educational articles, or anything that shows up from extension, that's tagged as biosecurity will show up when you click that link. The next one is for the Pennsylvania Department of Agriculture's Animal Diagnostic Laboratory System. And so this is where Pennsylvania is tracking HPAI and putting out information on where various outbreaks have been confirmed. The third one, which Chris did already put in the chat, which was great, is for EPA's pesticide registration list of products that are effective against avian influenza. And this is a very overwhelming list. When you click on it, there are pages. There's more than 15 pages of disinfectants or antimicrobial products. But what I like about it is you can sort it by contact time. So like I said, some of these products require like 5 to 10 minutes of contact, but there are other products that only require 30 seconds before they dry and they are considered effective. So I highly recommend, looking for a product that requires a lot less wetting and contact time, but still is effective. And then the last two actually, healthyagriculture.org is a website that's run, I believe, by the University of Vermont, if my brain is working this morning. And it's a whole website solely about biosecurity. And then the last link is really very similar to the first link. However, they actually have a page specific for service providers. So conservation professionals, anyone that's showing up on the farm as a service provider, and they have some trainings there. And so it's just a great place for general biosecurity information. Ask me any questions you may have on biosecurity. All right. Well, if you think of any questions on biosecurity, feel free to reach out to me directly. I'm going to put my email in the chat right now. You can reach out to me directly at guc123@psu.edu. Thank you, everyone.
Thank you, Jenny. Okay, our last presentation for today will be Katie Brooks. She's going to talk about fish and wildlife, an introduction to fish and wildlife, and how they pertain to conservation. Katie, if you are ready.
Yeah, thanks, Chris. I'm going to go ahead and share my PowerPoint.
Go ahead.
Okay.
All set.
Does it look good?
Yep, looks fine.
Okay, perfect. Okay, so I'm Katie Brooks. I'm a forestry and wildlife educator here with Penn State Extension. I am based out of the McKean County office, so I'm in north central Pennsylvania, but I cover the entire state, and I'm happy to help anyone in any county with any questions that you might have. So there's my contact information. I can also put this up again at the end if you think of any questions at the end. But today I'm going to cover an introduction to fish and wildlife. So the objectives for this presentation today are to talk about why fish and wildlife need to be considered when we're thinking about conservation planning or any kind of planning that's taking place on a farm. So we want to understand the resource concerns of importance that pertain to wildlife. And then at the end, I'll start to talk about how we can look at the agricultural landscape as an interaction of many different systems that can complement each other and serve multiple purposes, how we can get them to work together between wildlife and farming. So, wildlife, why we're even talking about wildlife or why we're talking about it as resource concerns. is that just like any resource, it has a value, but its value varies depending on an individual's viewpoint. So why should we even think about wildlife on a farm if it's not one of the farmer's objectives? Why are we even covering this if it's not something that's of importance to a farmer? And that's because we have to consider wildlife because it's a public resource. So just like water is something that is freely used by the public, air, fish and wildlife are also considered a public resource. And we consider it a public resource because of the history of our country and how our country was founded and some of the things that have shaped it along the way. So in Europe, the land, crops, livestock, trees, wild game were property of the landowner. So in Britain, the model of wildlife ownership was limited to the king having full ownership of all living wildlife. So the king was considered the landowner, and they were considered to own everything that resided on the land, and that included the wildlife. Only the king could grant rights to hunting, to the land, to fishing, to people of choosing at his will. So the king would even gift these rights to individuals other than the person that owned the land. The king could choose to gift the rights of hunting or fishing to people that didn't own the land. So in essence, the king managed all natural resources and wildlife for the people, but he remained the only one to own the rights of the wildlife in the land. Once, America was colonized, North America decided to handle wildlife ownership much differently than in Britain. So in this case, there was no monarch to own all of the land and all of the natural resources that lived on it. At first, there was kind of this take what we want mindset with North America, or with settlers. And because of that, we saw the decline or the extinction of some species. And so because of that, this mindset shifted from take what we want to good of all mentality, as we saw the impacts of those different wildlife populations. So now in North America, wildlife is held in the public trust and states act as the managerial trustees for the public. So this is actually known as the North American model of wildlife conservation. The vegetation, domestic animals, land can be owned by landowners, but fish and wildlife are public property managed by the state. And so this is actually an article in the Pennsylvania Constitution that says natural resources are the common property of all the people, including generations yet to come, and the Commonwealth shall conserve and maintain them for the benefit of all people. So in Pennsylvania, our public resources, wildlife resources are managed by either the Pennsylvania Game Commission or the Pennsylvania Fish and Boat Commission, depending on if they're mammals or birds, or fish or reptiles or amphibians. So as a result of all of that past history that's kind of led to this North American model and all this, legislation and all of that, we have laws that oversee fish and wildlife as a public resource, which state and federal agencies must always consider, not just when it's a cooperator's or a farmer's choice. So I'm not going to go through all of these acts necessarily, but within each of these acts, there's wording that talks about how we must see fish and wildlife as a public resource and how they must be managed for the public good. So the landowner and the laws may not always have the same objective when it comes to wildlife. A good example, or any public resource, I guess. A good example is when we talk about manure. So in this example, a landowner may say, I need to spread manure in the winter because my pit is full. But the law says spreading manure can only be done at certain times and in certain ways to protect water quality because of the public benefits related to clean surface water. So we need to protect surface water because it's a public good, and we need to protect those benefits provided to the public. And so landowners are then limited in when they can spread manure. Another example would be wetlands. A landowner saying that they want to drain their wetland because they need more acres to graze their cattle. And the law says that some actions are not allowed in order to protect the wetland functions because of the public benefits they provide for water quality, infiltration, and then also the good for wildlife that wetlands provide. So again, we have to consider fish and wildlife because like in those examples, it talked a lot about water being a public resource, but fish and wildlife are also a public resource. So what specifically is farmland wildlife? It doesn't include every species of wildlife in Pennsylvania, but those species that we do see on a lot on farmland are the wildlife that live in open, non-forested area. So a lot of grassland species and also some edge species. And these species include some of the fastest declining wildlife groups nationally, which are grassland birds. So grassland birds have seen a 60% decline over the last 40 years. And so they're really of top priority and top concern for conservationists. And so that's why we really focus on them when we're talking about farmland wildlife. So why is farmland wildlife declining? We kind of look at this in two ways. There's natural occurrences that cause declines in wildlife or the unnatural or man-made. So predators and diseases are natural occurrences. Historically, in Pennsylvania, wolves and mountain lions would have been major predators, but they've been extirpated from the state. So now we have things like coyotes, foxes, birds of prey are all natural predators, as well as humans to some extent for some species. We also have diseases that are natural control. So we have things like chronic wasting disease when we talk about deer and the avian influenza for birds. And those are natural, always commonly occurring things that decrease or control wildlife populations. So when we talk about predators, we have a couple relationships that we can look at for how predators affect different wildlife populations. You have cycles where populations go up and down naturally. Prey species may decline for some reason, like normal disease outbreak, lack of food, harsh winter, and we see a tailing effect of a decline in predator populations because of that. A lot of this is called a hawks and foxes syndrome. But then as our prey species starts to recover, and the populations increase, we see, again, our prey species increase as well, because it's a directly related relationship. So predation on prey species is normal, typically won't cause a decline in our prey species unless there's something else wrong. So loss of habitat or a new novel disease. And another thing to remember is that predators are wildlife too. They can a lot of times get a really bad rap and be seen as the reason for why there's a decline in some of what we might see as more valuable or more desired species. But predators are wildlife too. They're part of what we have to consider when we're thinking about wildlife on a farm. And they may even be prey for other predator species as well. So they all have a place in the food web. And then if we talk about the other side of natural decline, are diseases. So things like rabies, HPAI, chronic wasting disease, West Nile virus. And these actually have less effect on wildlife than commonly believed. Obviously, there are some instances where these diseases, CWD can decimate a population, HPAI can get into an area and decrease the population. But unlike domestic wildlife or domestic animals, wildlife has much more natural tolerance or immunity to a lot of these diseases. And then when we have disease on farms, we see an issue in things like poultry flocks because all the birds are contained into one area and they're able to more easily spread the disease. In most cases, wildlife is more dispersed, so there's less transmission, and you're going to see less of a decline as a result of these kinds of diseases. And same with chronic wasting disease. We really are only seeing issues in deer populations in areas where they're really densely contained. So rabies is kind of the same thing. There's positive reports of rabies in wildlife regularly, but it really doesn't cause any widespread population decline. So even though these diseases are occurring and can have some effects on population, it's generally not enough to decline the population significantly. So then we can start talking about the unnatural occurrences that are causing population decline. One of those would be the use of pesticides. I'm sure everyone has heard about the bald eagle decline in the 1960s from the use of DDT. And if you're not familiar, they were being poisoned with DDT when they ate contaminated fish. And this chemical interfered with the ability of the birds to produce strong eggshells. So as a result, their eggshells were so thin that they often broke during incubation or just otherwise failed to hatch because of the thin shells. So the banning of DDT helped the eagle population to rebound, and that's an example of an unnatural decline. So typically pesticides are not directly killing wildlife, but affecting the plants or insects that they're feeding on. So any harm done by pesticides is usually an indirect effect of the chemical. It can kill plants or insects, which reduce food resources, less food available, and then we see a decline in populations. Another issue can be bioaccumulation, where it's absorbing into plants or insects and then being transferred into wildlife that are eating that affected pest. And typically with pesticides, the issues are not widespread. They're very localized to the area that the pesticides are being applied and affect just a few individuals at a time. And these issues are easily reduced by using pesticides and herbicides in a way that's consistent with label restrictions and just following the regulations, making sure we're using them correctly and monitoring how much of them we're applying. So what it really comes down to when we're thinking about farmland wildlife decline is large-scale habitat loss. Certainly the other things, predators, diseases, and pesticides are all concerns, and they can all interact to make the situation worse, but they're mostly manageable. Large-scale habitat loss is the number one reason why we're losing farmland wildlife. So to talk a little bit about what we can do to manage that issue, we need to think about what are the resource concerns for wildlife, what are the things that they need, and how can we manage those and improve them on the farmland we're working on. So it's probably pretty obvious, but all wildlife need food, cover, and water, and they need all three of those. Typically in Pennsylvania, water is readily available and not limiting. So we don't usually talk about water as a resource concern for wildlife. They also need to have all three available throughout the entire year. So we don't need to just think about having these, in one season, but we need to think about all seasons throughout the year that food, water, and cover are available. And a good example of thinking about this, is that we see large-scale migrations of birds in the fall because their food sources are decreasing just due to seasonality. So they go places where food is readily available, like the tropics, where a lot of our species migrate to. And then when these foods start to become more available in the spring and summer, they start to migrate back. Not all animals have the luxury or ability to migrate, and so we have to think about providing for them throughout the entire year. And it's not just food, although that's the example that I gave with migration. Cover may also be seasonally unavailable for some species, especially when we start thinking about farms. So this is a chart of the different resources available throughout the seasons. Like I said earlier, water, which is the blue line, is pretty available all year. We might see a little bit of a dip in the summer, especially if we have an especially dry summer, but typically throughout the entire year, they're going to have access to water. And then when you get into fall and winter is when we see food and cover decline. That's when we start to see, species moving, our birds migrating to get to a place where those resources are more available. So when we're talking about wildlife, vegetation or habitat is the key. Vegetation is both food and cover. It's protection from predation, it's places for nesting, and it's things for them to eat. A lot of wildlife practices really focus on habitat. And so this, a little bit of my backstory is I originally was studying wildlife at Penn State. That's what my bachelor's degree is in. And I started to shift into more forestry related work because I realized the importance of habitat. There's a quote I once heard, it says, habitat isn't everything, it's the only thing. If they don't have habitat, if wildlife doesn't have habitat, they won't survive and they'll move elsewhere. They'll leave the area if there's not enough resources for them. And so that kind of led me into focusing more on forestry and understanding the habitat side of things, because that's really the only part of wildlife we have control over from a landowner or a land manager or a farmer perspective. Unless we're working for the Game Commission or Fish and Boat Commission, we don't have a lot of control over the wildlife individually. But what we do have control over is managing habitat and making it as diverse and hospitable as possible. So how can we affect vegetation in farmland? How do we manage for wildlife in the conservation practices that we're using? Some options include crop rotation, which help provide both food and cover. Crop residues, again, provide food and cover crops. Practices like long-term vegetation, like buffers and interspersion, help break up the habitat and are important for cover as well. Part of evaluating wildlife habitat, looking at what you have, includes looking at the distance to cover, or how large a field is and where there is uninterrupted cover on or around a field. And I'll get into each of these specifically. So for crop rotation, more diverse rotation is always better for wildlife. The more number of different species, the better. So with different types of food sources, different types of crops, we're going to see a higher variety of insects and seeds, which is going to promote a higher diversity of food available for different types of wildlife. If there's cover crops, the more time there's cover on the ground, the better it is for wildlife, because obviously it's increasing cover. Bare ground is not often very good for wildlife. So as long as if there's something that can be on the ground, that's going to be better, and it's going to increase the available food throughout the year as well. And then there's crop residues, which are important for soil health and erosion, but it's also important for wildlife. A lot of times in retaining some cover for winter, you're providing like exponential benefits for animals, food sources and cover for animals that don't migrate or hibernate. And things like horn larks and other grassland birds will come through and forage in those low crop residues. Then there's also cover crops. They're great for all sorts of reasons, and they're practices that I'm sure you talk about with farmers all the time, but not just for the reasons that we typically think of, but also for wildlife. They're great for providing food and cover during a time of year where there typically isn't much, when resources are scarce. So we compare the field on the left versus the right, you can see the increased opportunity for food and cover there, and imagine the benefits that it would provide for wildlife. And then there's food plots and other cropping activities. Food plots are often a choice that people make because they're interested specifically in helping wildlife, providing benefits for wildlife, or having increased hunting opportunities, or because they like to bird watch. So they're also an option to provide cover and food during stressful times, again, when resources are scarce. Another option outside of food plots is to just adjust the cropping activities to something like a delayed harvest, or not harvest anything at all for maybe a portion of a field, maybe somewhere on a field border or an edge that borders a forest. That's going to provide food and habitat for wildlife and increase your opportunities for things like bird watching and hunting, but maybe not be as much resource input as a food plot. So lunch, I think, is coming up here pretty soon. But if for an example to kind of think about this idea of diversity of habitat and diversity of vegetation, if you had only 2 food options for today, all day, your options would be 1, a Pop-Tart, or you can have eggs and toast for breakfast, a sub with turkey, cheese, lettuce, tomato for lunch, and a grilled chicken, potatoes, and broccoli for dinner. Which would you choose and why? And which do you think would benefit you more? So if we're thinking about a human's daily food, you're probably getting more nutrients from that second choice, that variety of food, than when you and when we talk about a human diet, when we talk about things like a food pyramid, the variety of foods is better for getting more of those nutrients that we need. So that's why our human food plans talk about eating a variety of foods that include fruits and vegetables, proteins and carbs. And so that's also important when we think about wildlife, having that variety of food available. So when we talk about vegetation type and perennial plants, they're going to offer more benefits than annual plants because they're more long-term. And typically we're going to recommend using native species over non-native species for wildlife benefits. So if we look at something just like warm season grasses and cool season grasses, they provide really great habitat for species and wildlife is adapted for. So things like our Indian grass, switchgrass, big blue stem, all native to Pennsylvania and really good for wildlife habitat. Warm season grasses are varieties that are in active growth beginning in the late spring and go dormant in early fall. So they have a shorter growing season than cool season grasses, but provide a lot of benefits during their growing season. Especially bunch grasses are really great, providing habitat and cover and still allowing movement for small animals. And yeah, they allow wildlife to move through the grasses while feeding and looking for shelter. It makes them great nesting cover for upland game birds and different ground nesting songbirds. Deer will also hide their fawns in those grasses as well. And with warm season grasses, the tall stems can also remain standing during the winter, which provides great winter cover for rabbits, game birds, waterfowl, small mammals. They're also able to rebound after being covered with snow, while cool season grasses would remain matted down. And then our cool season grasses also have benefits as well. They're in active growth or green up early in the spring, stay green into the fall before going dormant. So they're some of the first available food for many species of wildlife. So if possible, having a mix of these, if there's areas that aren't necessarily the best for farming or best for crops, maybe getting these into those areas as a cover is a great option. And then one reason why we always promote native plants are we just don't know all of the effects of non-native plants on wildlife yet, but we know that native species have greater benefits to wildlife than non-native species. And so this is something I like to throw into a lot of the presentations that I talk about just to really emphasize the unintended consequences of in non-native species. So a few years ago, citizen scientists started to notice that a species of bird called a yellow-shafted flicker were seen with red and orange plumage. They originally scientists believed this might have been hybridization with a bird called a red-shafted flicker. But then a new hypothesis started to emerge that the reddish hue was caused by a pigment found in the berries of 2 types of invasive honeysuckle shrubs. And so a professor from the National Aviary started looking into this and doing some research and showed that when cedar waxwings were eating these berries from honeysuckle, their feathers were taking on an orange cast caused by the pigments found in the berries. So typically these the cedar waxwings would have yellow tails, and they were being seen with more orange-red tails after being found to feed on these honeysuckle fruits. They don't know exactly yet what effects this might have, but there are some theories that this could impact the way that birds select mates, because coloration is very important. Plumage is very important for mate selection. And so down the road, this may have some implications there. So another easy practice that can be done on farms is just to remove non-native species where possible, or just don't introduce them at all. Then we have interspersion, having cover and not having cover. So if you're a mammal in the field on the left and there's a hawk flying overhead, they're going to be able to see you. There's nowhere to hide. If you're a small mammal on the right, while it is far to those trees and they're spread apart, there are places where you can get to cover and hide from predators. There's also ways to get out of the elements through winter storms, and any little cover like that is definitely beneficial. There are also species that hibernate and look for areas like these trees with roots that they can hide. So one example would be bog turtles. We don't typically see them on cropland, but when they hibernate, they're under the roots of woody plants. So they're looking for areas with trees to have protection from winter. And so another example to kind of think about this idea of interspersion is if you have donuts on a table at the back of a meeting room, there's 6 donuts on the table, and then there's 6 hidden around the room. Which donuts are going to be eaten first, and which ones might not survive, might survive the whole day. You would expect that as people are walking into a room and they see donuts on a plate, they're going to eat those, as opposed to looking around the room for hidden donuts. And so this is just emphasizing the importance of having cover and habitat for protection. So those animals that are out in the open are likely to be the first ones picked off. And if there's some kind of cover and protection for them, they're more likely to survive. So how do resource concerns for wildlife fit in with farming? And this is where I want you to start thinking about the agricultural landscape as an interaction of a bunch of different systems that can complement each other and serve multiple purposes. So when we're talking about farmland wildlife, we need to look at the whole landscape. And we need to start thinking about where wildlife habitat fits into the systems that are already in place. We don't need to specifically set aside land for habitat, but instead look at where we can incorporate wildlife habitat into the system that already exists. Where can habitat and cropping work together? It doesn't need to be the primary goal of the plan, but where can it fit? Or where are there unused or unsuitable portions for farming that could be better utilized as wildlife habitat? So in this picture here, you can see a variety of practices. There's things like a forested riparian buffer. There might be some wetland areas. In those forested areas, there's filter strips of perennial grass. And so this shows that there can be that intermix of farming, but utilizing some areas that aren't ideal for farming and improving them for wildlife habitat. So all of these things, grasses along strips, riparian buffers, they're typical practices, I think, in a lot of cropland systems, but they're also beneficial to wildlife as well. And so a lot of practices, like I said, can be incorporated right into an existing system. So buffer strips or a riparian buffer, filter strips, they're very beneficial to wildlife. They can be small commitments, don't typically take up a lot of land, and a lot of the time the land that they are taking up is already unsuitable for farming. Obviously, farmers really want to farm as much land as they can because that's where they are going to make a profit. So it's really about looking at things a little differently and seeing where the habitat benefits and habitat features can kind of fit into the whole system and try to think about utilizing all the space for good in some way. So these are the practices that we really look for wildlife benefits, and also affect other things. So if we're already planning crop rotation anyway for soil erosion and soil health, it's also beneficial for wildlife by providing that variety of food throughout the year. Leaving residues, good for the same thing for our soil erosion and soil health, and also good for wildlife habitat and wildlife cover. And also when we think about things like water quality. So really 2 to 3-fold benefits from a lot of these things that farmers are probably already doing. So these are things that you're probably already discussing with farmers all the time. So wildlife fits right in there because it's not new or different, but it fits into the practices they're already doing or practices they're already thinking about. And maybe you can encourage them that way towards doing some of these things because of the benefits for wildlife. So when you're talking to farmers about doing any of these things, you really can emphasize how these practices can affect things like soil erosion, soil health, nutrient management, water quality, things that they're also thinking about, and also their profitability. But you can also mention the benefits of doing these things for wildlife as well. So we know these practices are good for many things. So if we just tweak them a little bit, they'll work for wildlife too. Things like extending cover crop or delaying mowing, or making a field smaller. Those things will help increase the benefit to wildlife habitat. So I think the big takeaway and what you can take to farmers is that wildlife and agriculture don't have to work against each other. A lot of the times it's things they're already doing, things they're already considering, that can be beneficial for wildlife. So to wrap everything up, everything that I covered today, I hope after this you understand why we have to consider fish and wildlife when we're conservation planning or talking with farmers. And that's because they're a public resource, just like air or water. The state does regulate how they're managed, and we're required by law not to cause detriment to these things because they're a public resource. Then I hope you understand the resource concerns of importance to wildlife. Specifically in Pennsylvania, that would be food and cover. Water is also important, but typically not limiting here. And we need to think about food and cover across the landscape and throughout the year. So not just at one point in time, but across the entire farm, across the entire landscape, and then through all the seasons of the year that those food and cover are available. And then I hope you can begin to view the agricultural landscape as an interaction of many systems that can complement each other and serve multiple purposes. So consider the wildlife potential of many of these common conservation practices that you're already doing and already discussing, and how they can be beneficial to wildlife at all, or what little changes can be done to increase wildlife habitat and diversity within a farm system. If you're interested in learning more, we have a lot of articles on the extension site under the Forest and Wildlife tab, and you can always reach out to me to answer any questions as well. And so with that, I can take some questions.
Great. Does anybody have any questions for Katie? Nothing's coming in right now, Katie. Thank you for your presentation.
Yep. Thank you, guys.
All right. That was our last presentation for today. Tim, I don't know if Tim is still on or not. Looks like he might have gotten off. So half of you we will see on Monday in Lewisburg, and the other half we will see in May. And then we'll have our last virtual day after the second round of Bootcamp Basic. So I hope you all have a great day. We'll see you Monday.